All right, hi, good morning, everyone. I hope you can hear me well. Please let me know if you can.
Good morning, I'm here.
Okay, wonderful. So we're gonna get into our session, but my name is Lisha Marie Whitaker, as you guys may have seen. I'll be a tutor for today. We're gonna be doing paper 1 for chemistry for CSEC. So I had sent a file in the WhatsApp group that we'll be going through today. We're gonna be starting at page 49. But I'm also going to be sharing it on my screen, and I hope that we'll have a good session, an interactive session. So let me start sharing my screen and then we can get started. All right, can everyone see my screen?
Yes.
All right, awesome. So before we start, we could probably just say a prayer just so that everything will go well. So I'll pray. Dear Lord, even as we're here, we just ask that you will be with us, that you'll help this session to be productive, and that you'll allow for anything that we go through today to be cleared up for students so that they'll do well on their exams. In Jesus' name, amen. All right, so we're going to start off with our first question, and it reads, which of the following processes provide evidence of the particulate nature of matter? So let me hear what you guys think for this question.
D.
Pardon me?
The answer is D.
D as in dog. All right, why would you say that the answer is D as in dog?
Because particular theory of matter has to do with the movements of particles from a region to another, and diffusion and osmosis fosters that.
Okay, good, good. That's actually a really good answer, right? So if we're looking carefully at this, when we're talking about the particulate nature of matter, we want to see proof that matter is made out of particles, right? So filtration and capillarity don't sufficiently, give evidence of this. And so the answers that we would go with would be D, 2 and 4. All right, let's continue. Mass number is the number of, what do you guys think the answer for this one is?
A.
A, all right.
A.
Neutrons plus protons, wonderful. All right, let's keep it going. Which of the following elements has 7 electrons in its outer shell?
D. D as in dog.
Dog, right? What's the collective name for elements with 7 electrons, in their outer shells?
Halogens.
Halogens, perfect, right? All right. Can anybody name some more halogens quickly?
Bromide, io.
Right, so we have fluorine, bromine, iodine, right? Those are the ones that you guys need to know. Fluorine, chlorine, bromine, and iodine. All right, let's keep it going. Number 4, an atom has 20 electrons when it ionizes, has 20 electrons, right? When it ionizes, it has the same electronic configuration as which of the following? So in its atomic state, it has the 20 electrons. When it ionizes, it has the same electronic configuration as which one of these?
Argon.
Argon, okay. All right, so tell us how you arrived at that answer.
I said argan because argan is gas, so it has its valence electrons are on its shoulder. And so it's a noble gas. And you know, noble gas is the valence shell is filled with all the electrons. So when this atom ionizes, it's going to become
it's gonna become all right. I think that was definitely a very, very good try. For this one, the answer is argon, so you did very well on that. In terms of explaining this, you could take one of two routes, right? So you could take a non-specific route, which would be to say exactly what our friend here just said, which is, okay, if this atom ionizes, then its electronic configuration is going to be the same as the nearest noble gas, right? So then you could talk about it from the specific route. Okay, so which atom is this? What element are we talking about, right? So we have 20 electrons, right? And if it's an atom and not an ion, then we know it's also going to have 20 protons. Which element has 20 protons? Any ideas, guys?
calcium.
Calcium, beautiful, right? So calcium has 20 protons. Now, when calcium ionizes, let's write it down, calcium, right? Now, when calcium ionizes, it becomes calcium what? 2 plus, correct? You guys with me? When calcium
Yes,
ionizes, it becomes calcium 2 plus, right? Now, if calcium 2 plus is this ion that it turns into, what happened when we changed from calcium to calcium 2 plus? Did we gain an electron? Did we gain 2 electrons? Did we lose 2 electrons? How did it go? Moving from calcium to calcium 2 plus.
lose electrons.
Right, so we lost 2 electrons, which means that the number of electrons at the end of ionization is going to be 18, right? Plus 20 minus the 2 that you would have lost, right? And as our friend was saying, it's going to gain the electronic configuration of the nearest noble gas. And the noble gas that has 18 electrons is going to be argon, right? So if you wanted to do it in a more shortcut way, it would just be, okay, it has 20 electrons now. When it ionizes, it's going to get the same number of electrons as the nearest noble gas. And if we're now at 20, the nearest noble gas would actually be before that, which is at 18, and 18 is argon. All right. Next question, question 5. So here we have 2 isotopes, right? We have sodium 24 and sodium 23. Now, why are these isotopes of each other? What's the reason? That's what the question is asking us. Pardon me?
C would be the answer.
Yes, C would be the answer, but why? Why is C the answer?
Because isotopes have different amount of neutrons, which will change the mass number.
All right, beautiful, right? So if we remember our definition of isotopes, we just said that they have the same number of protons, but they have different number of neutrons. And so in essence, at the end of the day, they're going to have a different number of, a different mass number, right? So that's essentially what we're looking at here, right? So they're isotopes because even though they have different masses, one is 24 and one is 23, they have the same number of protons, which means that by identity, these are the same, right? And so that's why we call them isotopes. All right. If you guys have any questions or need me to go back, please let me know and I definitely will. All right, so we're moving on to number 6. Sulfur and oxygen are in the same group of the periodic table because why would sulfur and oxygen be in the same group?
They have the same number of electrons in the outer shell.
Right, good, right? They have the same number of electrons in the outer shell. Wonderful, right? And so that's one of the things that we notice when we go down our group, right? That's what unifies the members of our group, right? They all will have the same number of valence electrons. What is it that unifies the members of a period, right? What is it that is common among the members of a period?
Have the same number of shells.
Beautiful, right? So if we're in period 3, then all the members of period 3 are supposed to have 3 energy levels, right? Or 3 shells. All right, beautiful. All right, now on to item number 7. Item 7 refers to the following quantities of atoms. All right. Which of the following pairs represents equal quantities of atoms? All right, so here, let's zoom in a bit. We have 12 grams of carbon, 16 grams of sulfur, 23 grams of sodium, and 12 grams of magnesium. So, which of the following pairs would have equal quantities of atoms? They also give us our relative mass number. So would anybody like to volunteer to talk about how we tackle this question? Pardon me?
Would multiply the masses by the mass number.
All right. Thank you so much. So in this case, because they asked us or they told us about quantities of atoms, right? And they also gave us a mass number. What do you think they're hinting at here, right? Whenever they give you a mass number and they give you a mass, they're really hinting at the number of moles, right? Now, what is the equation to find the number of moles of a substance or of an atom? Sorry, of an element, right? What is the equation to find the number of moles?
Number of moles equals mass over molar mass.
All right, beautiful, right? Number of moles equal mass over molar mass. Now here we can use our relative mass number for our molar mass, right? And so essentially what this question is really asking us to do is to find out the number of moles of each of these that we have. Because remember, moles have a certain amount of particles. Does anybody remember the number of particles of a substance in a mole?
6.02 times 10 to the 23rd.
Beautiful, 6.02 times 10 to the 23rd particles, right? So whether that be atoms, whether that be molecules, etc. Now, if we know that the 1 mole of a substance has this amount of particles, that means if we have 1 mole of carbon, for example, and 1 mole of sulfur, for example, then they're supposed to have the same amount of particles, right? And so in essence, this question is just saying, okay, here we presented you with different weights of different substances. Which of these has the same number of moles as each other, right? So here we are now. Looking at this question, it would be important to say, okay, let's calculate the number of moles. So for number 1, which is 12 grams of carbon, how many moles is 12 grams of carbon? Any ideas, guys? 12 grams of carbon. Remember, we just said that the number of moles is mass over molar mass. Go ahead. I think Regina just opened her mic. All right.
1.
All right. Lovely. Thank you. Right. So now it's 1. And how did we get 1? Because we said number of moles equal mass over molar mass. The mass we were given was 12 grams. And we're putting that over 12 grams per mole. And that will give us 1 mole. Now for the rest, we can just do those swiftly. 16 grams of sulfur, that would be 16 over the RMM, which we got as 32, and that would give us 0.5 moles, right? Number 3, 23 grams of sodium, right? So we say 23 grams over 23 grams per mole, right? And that would give us 1 mole. And then we also have 12 grams of magnesium, right? 12 grams of magnesium. All right, so that would give us 12 over 24 to give us 0.5 moles, right? So what we can do from even before we look at these answers is to pair them ourselves, right? So that means 1 and 3 have the same number of moles. So that's 1 pair. What's the other pair that has the same number of moles, guys?
Two and
2
4.
and 4, miss.
2 and 4. Beautiful, right? 2 and 4. So now we're going to look at the answers that they give us. Do we see 1 and 3 here? No, right? So that means we need to be looking for 2 and 4, and they have it here as D. So the answer here is D, 2 and 4. Did everybody understand that one? You want me to go over it? Just let me know. All right, so I'm gonna assume that everybody understood. So when we get to another question like this, we're gonna review this and see how we fare out, right?
Yes, miss.
All right, beautiful. Now, question number 8. An ion with a single negative charge may be converted into a neutral atom by
C, miss.
all right, so I heard D. Okay, I heard B as in boy. I see B here in the chat. All right. So for this one, right, it says it has a single negative charge. Which of the subatomic particles has a negative charge to it?
Electrons, miss.
Electrons, right?
Miss, it
No.
to be C.
Right. Beautiful. Losing an electron. Now remember, we don't lose protons. We don't lose neutrons, right? We're not talking about radioactivity at all, right? So it wouldn't be A because we don't lose our neutrons. And it wouldn't be B because, as we said, we don't lose our protons or gain protons. Because if we did that, then we would have a totally different substance, right? But then for D, why is it not D? It's because here we want to move from -1 to 0, right? So what would we have to do? We'd have to get rid of this -1, right? In order to get back down to 0. And so we'd have to lose an electron in order to do so, right? Because we said we're moving from a single negative charge to neutral, right? All right.
Yes, miss.
Okay, good. Wonderful. All right, now we're going to be moving on to question number 9. Please let me know if I'm moving too fast or too slow for you guys. All right. So sodium reacts with water according to this equation that we have here, right? We have a beautiful balanced equation. Now the molar volume of a gas, right, at room temperature and pressure is 24 liters, right? Now, the number of liters of hydrogen, right, that is produced at room temperature and pressure when 0.1 moles of sodium reacts, right, with excess water is, so they're asking us how much hydrogen is being produced at room temperature and pressure if we used 0.1 moles of sodium. All right. So I want to hear your answers and then we're going to walk through it. So what do you guys think this one is? I'll give you some time to, finish the question and then we can discuss it.
Yes, miss.
All right, guys, as soon as you have your answers, just let me know what you guys thinking, whether it be A, 1.2, B, 2.4, C, 12.0, or D, 24.0. You can either put it in the chat or you can say it out loud.
Yes, we can go ahead because we answer, for record this.
All right, thanks for letting me know. All right, so we're gonna go through this one now so that you can understand, right? Okay, so when you get this question, what are some of the things that jump out at us? They gave us this quantity here, the molar volume of gas. What gases do we have? We only have hydrogen. But what does it mean, the molar volume of a gas, right? This just means the volume of 1 mole of the gas, right? So that means
Yes.
the volume of 1 mole of hydrogen at room temperature and pressure is going to be 24, right? Now, in order to really calculate this one, we already have the equation. So what do we need to do? We need to look to see what else they give us, right? So they told us 0.1 moles of sodium is what reacts. Now, if we're looking carefully at sodium and hydrogen, we will notice that there's a 2-to-1 ratio of sodium to hydrogen. So let's write it. Sodium Na to hydrogen gas is 2-to-1. All right. So now that we have this 2-to-1 ratio, what else do they tell us? They said it's 0.1 moles of sodium. So what does that mean for us? If we use 0.1 moles of sodium,
It must
then
be half.
right, we need to see how much it is for hydrogen, and we know that that's going to be half, right, of the 0.1. So this question mark will turn into 0.05. Does everybody understand how we got the 0.05?
Yes, miss.
All right, awesome. So since we know now that we use 0.05 moles, or we produced 0.05 moles of hydrogen, then we can move on to our next step, which is if we have 0.05 moles of hydrogen, and we know that for every mole of hydrogen, we're going to get 24 liters of hydrogen, we are trying to find how many liters are in 0.5 moles, right? So what we're going to do is that we're going to take this 0.05 moles and we're going to multiply that by our constant, which is 24 liters per mole, right? At RTP.
Yes, miss.
And what does that give us? 0.05 times 24.
1.2, miss.
Good. 1.2, right? And so that's how we get our answer to be A. And if anybody didn't understand that, or you just want me to go back through it, I don't have any problems doing so. Just let me know, okay? So did everybody understand how we got the 1.2?
No.
All right, no? All right, let's go back through, right? So let me use a different color as we're walking through, right? So as we said, we have 2 to 1 here, right? That's the first step. Noticing the ratio of reactants to products. So that means that if we were to have used 2 moles of sodium, then we would get 1 mole of hydrogen. Does everybody understand that part?
Yes, miss.
Yes. All right, great. So if we understand that part now, then we can look over here at our mole ratio. Another word that you might see is stoichiometric ratio, right? Now, as we said, that's 2 sodiums to 1 hydrogen molecule, right? So then we're going to look at so this is just the ratio, right? Now then we're going to look at the question, and the question says that we actually use 0.1 moles of sodium, right? Now, if we use 0.1 moles of sodium, then we're going to produce half that amount of hydrogen. So you would get 0.01 divided by 2 to give us 0.05 moles. Everybody understand up to that point?
Yes, miss.
Yeah? All right,
Yes,
awesome.
miss.
So if we understand up to that point, then the next thing, once we know the number of moles of hydrogen that we produced, is to find out what volume is that, right? And as we said, when we define it, the molar volume of a gas, right, is the volume of 1 mole. Let's write that again. Molar volume equals the volume of 1 mole, right? And the units for that would be here, liters per mole, right? Now, if we want to find liters and we have liters per mole and we have the number of moles, then what we need to do is multiply, right? So let's make some space. What we're gonna do is multiply, as we said, right? So we said we have 0.05 moles of hydrogen, and we're multiplying that by the volume of 1 mole of the gas, and we know that that volume is 24 liters. So what is 0.05 multiplied by 24? Any answers, guys? 0.05 times 24.
1.2.
1.2. Beautiful, right? And so that's how we get our 1.2 liters. Does everybody understand how we got to our 1.2 now?
Yes, Miss.
Yes, miss.
All right, beautiful. So now we know that we have 1.2 liters of hydrogen being produced. All right, beautiful. We're going to see some more questions like this, so we'll get a bit more practice. So just in case you kind of get it, but you don't really get it, before we leave today, we want to get it. We want to really understand it, right? All right. So what you'll notice is that a lot of the questions, not a lot, but a few of them are more theoretical questions, right? So sometimes instead of asking you to work with actual chemicals per se, they will give you little hints, right? And ask you or give you theoretic chemicals like what you're going to see here in question 10, and ask you to answer questions based on the chemicals you already know about or based on the elements you already know about, right? So let's look carefully at question 10. A new element, brand new, element R, shows chemical properties similar to the element sodium, right? Does anybody know any of the chemical properties of sodium? Anyone know any chemical properties at all for sodium? Right? It's not something that you're going to need to know in depth, but what I do want you to know is that sodium is one of our most reactive metals, right? That we have. So what you need to also know is not just that it's one of the most reactive, but how many electrons are in the valence shell of sodium?
One.
One, right? All right, beautiful. So what is the question that they're asking us about this? So they say essentially it has the same chemical properties. So they're now asking us, what is the correct formula of a compound that is formed with R and sulfur? Remember now, R is our brand new element that has the same chemical properties as sodium. Now, what you'll notice is that elements with the same number of valence electrons will have similar chemical properties, right? And so here now they're saying R has the same number of valence electrons as sodium. So what is the correct formula of R and sulfur? How many valence electrons does sulfur have?
2.
2. What group is sulfur? Right, 6, right? So sulfur is in group 6, so it has 6 valence electrons. So in order to get to a stable state, it needs 2, right? Now, as we just said, R can only provide 1. So how many R's do we need to satisfy sulfur?
2.
Beautiful, guys, 2, right? So what would be the correct formula according to the fact that we need 2 R's to satisfy 1 sulfur? Which of these is the correct answer here?
Miss C.
C.
Miss.
C, beautiful, right? C. So when you guys see questions like these, it's important to just break them down, right? Because they give you hints along the way. But it's important to note for this question that if they have the same number of valence electrons, then they will have similar chemical properties, right? So if you write that down, then it will help you out a lot as we move forward. An example of this would be like the halogens, right? So we know that our halogens they react typically in very similar ways, right? And so what you'll notice too is part of the reason for that is because they have the same number of valence electrons. All right, that's all you need to know at this level. Number 11, barium is below calcium in group 2 of the periodic table, right? Question, group 2, those are metals or non-metals?
Metals.
Metals, beautiful, all right. When both metals react with water, the main difference in observation would be the rate of reaction. Let's mark that down. The rate of reaction is different. But what else is different here? Is it the type of product? Is it the type of gas evolved? Is it the reaction with litmus paper? Or is it the solubility of the product? A. All right, so we have one person for A. Anybody agree or disagree with A? All right, guys. So for barium and calcium, when we react them with water, what kind of product do we get? Do we get a hydride? Do we get a oxide? Do we get a hydroxide? What do we get when we react calcium and water and barium and water?
Hydroxide.
All right, so both of them are hydroxides, which means that the answer would not be A, right? Because the type of product is the same. Understood? So, all right, awesome. So since we know that now, right, what I want you guys to look at is we have calcium hydroxide and we also have barium hydroxide, right? What's the major difference between these two things?
D.
D, right? It's the solubility of the products. Which of them is more soluble?
Calcium hydroxide.
Right, calcium hydroxide. So what you'll notice is that a lot of hydroxides are not very soluble, right? But as you vary down the group, they become even less and less soluble. So that's why barium would be more so on the insoluble side of things, right? And then calcium would be, you know, partially soluble, right? And so here the answer is D as in dog. Now, what would you observe with a reaction with litmus paper with calcium hydroxide? Would it turn red litmus paper blue or blue litmus paper red?
Red litmus paper blue.
Beautiful, right? Because as we know, calcium hydroxide, barium hydroxide, basically all of our metal hydroxides, these are basic, right? And so when it's basic, right, then it's going to turn red litmus paper to blue, all right? All right, let's keep going. If you guys need me to go back, please let me know. All right, question number 12. Which two of the elements above, when combined with each other, form mainly ionic compounds? So the first question we need to ask ourselves is, what are ionic compounds? Can anybody answer that for me?
It's when a metal is bonded with a non-metal.
Beautiful, right? That's when a metal is bonded with a non-metal. So if we know what ionic compounds are, then we can start looking at what we're presented with, right? So we have some atomic numbers here. all of them fall within the first 20 elements that we're all supposed to know, right? So if you guys haven't taken the time to just, go through it, just make sure for your exams, you at least know the first 20, right? Now, here, we're looking at number 1. The atomic number is 3. Does anybody know which element they're talking about here?
Lithium.
Lithium, beautiful. All right, the next one, the atomic number is 6. Does anybody know that one?
Carbon.
Carbon.
Carbon, beautiful, right? The next one, the atomic number is 17. Anybody know that one?
Chlorine.
Beautiful, chlorine, right? And finally, we have 18, right? Which is that?
Argon.
Argon.
Argon, beautiful. Now, we know that we have lithium, carbon, chlorine, and argon. Which of these pairs, that's what they're asking, right? When you put 2 of these together, they're going to make an ionic compound. Which 2 are they? Right? So which 2 will give you an ionic compound when put together?
Lithium and chlorine.
Lithium and chlorine, beautiful, right? So that would be B as in boy, right? Now, if they were to give you some bigger numbers, right? Some stuff that you didn't really necessarily know what they were going to be, the next way to tackle this question would be to do the electronic configurations, right? Now, for lithium, it is 2, 1. For carbon, it is 2, 4. For chlorine, it is 2, 8, 7. And for argon, it's 2, 8, 8, right? And so if we know our electronic configurations and we know about groups and trends of the periodic table, then we will know that if it has a valence electron number of 1, we're looking at something in group 1, and group 1 houses what kind of atoms or elements? Metals or non-metals?
Metals.
Metals, right? Group 4, does that have metals or non-metals?
Metal.
Is carbon a metal? That's the
No.
important thing, right? So that would mean that we have non-metals here, right? All right, what about group 7? What do we have here? Metals or non-metals?
Non-metal.
Non-metals, right? And in group 18, what do we have? Sorry, group 8, what do we have?
Non-metal.
Non-metals, all right. Now from there, it would be important to do what? To start to identify what these could be or how the things in each group would react. So for our group 1 metals, we know that these are more reactive metals, right? And so they only have 1 valence electron to give away, right? And they're not holding on to it. They will give it up freely. Why? Because that's their barrier to stability. They just need to give up 1 to become stable, right? And so they will freely give that up. That's why they're so reactive. When we get down to group 4, they have half of the number to be reactive, right? Or to become stable. And so they don't want to give up their 4, right? Then we get to group 7. Group 7 is willing to accept the 1 that it needs. It just needs 1. And so it's very reactive with metals. When we get to group 18 or group 8, group 8 is already stable. So it doesn't need anything, right? And so when we look at these, it would be easy to say then, okay, for there to be an ionic compound, 1 has to be in it, right? So we'd have to X off C and D, but then we have to choose, okay, which of these non-metals is going to be most likely to react? And that would be the one in group 7 because it only needs 1 to become stable, right? And so that's how we got to 1 and 3 being the answer for this question. All right. If you guys need me to go back over that, just let me know. All right. Don't be afraid to ask questions or to say you don't understand. All right. Number 13. All right. So this question says that items 13 and 14, so I have to look at 14 as well, refer to the following terms. Now we have a giant ionic structure, sorry. B, we have a simple molecular crystal. C, we have a macromolecular structure. And D, we have a giant covalent structure. All right. So here we have a few different structures, and we know some of the differences between them. So calcium chloride, what kind of compound is this? Is it ionic or is it covalent? That's the first question to ask yourself.
Ionic.
Ionic. All right. So I heard ionic and I also heard covalent. So now this time we're gonna have to just break it down a little bit more, because right, we have to really get this one right. So calcium is a metal and chloride or chlorine is a non-metal, right? And so we know that if we have a metal and a non-metal coming together, they form an ionic structure, right? And so for our calcium chloride, we're going to be choosing A. Everybody understand why we chose A for this question?
Yes, miss.
All right, does anyone disagree or think it should be something else? Feel free to let me know, okay? Now on to number 14. 14 is starch. All right. What is starch, guys? You don't have to know it from a chemical perspective. Just let me know what is starch on a whole. If you do bio, you'd know what starch is, right? So what is starch?
It's 5 glucose components that are 6
It's a carbohydrate.
All right. So we find out that this is a carbohydrate. It is made up of glucose molecules, right? This one is organic, right? Now, what you'll notice with starch, which is also what you will notice if we're looking at polysaccharides, or if we're looking at cellulose, right? These are macromolecular structures, right? Macromolecular structures, C, right? Now, why do we say that these are macromolecular structures? Because essentially, you are making a polymer, right? So let's say this is one sugar molecule. Let me put glucose because it's glucose. We're at CSEC now. We don't need to say sugar. We can call it what it is, glucose, right? The glucose is bonded to another one, bonded to another one. And so this is a polymer, if you're really looking at it, right? And so that's how we get our starch, right? So our glucose molecules are bonded together through a condensation reaction to form a polymer. And as we know, polymers are macromolecular structures, and that's why our answer is C. Does anybody not understand or want me to go over it? Or do you want to see what glucose looks like as a chemical so you can kind of see it in your head? Let me know. All right. All right. So it looks like everybody's okay. So let's move on to our next question. Question 15. A separating funnel can be used to separate a mixture of which of these two? All right, so we got
B.
a B. B. All right, beautiful. B. Why is it B though?
Because the separating funnel is used to separate two liquids that are soluble in each other.
Right, beautiful, right? So they're used to separate liquids that are immiscible, right? That's the term we're looking for, immiscible, right? Two immiscible liquids. So remember, oil and water are immiscible. When you think of kerosene, I want you to think of oil, right? So oil and water are immiscible. Why? Because one is way less dense than the other. So the kerosene is going to float on top of the water, right? So we're going to have our organic phase, which is the kerosene. And we're also going to have our aqueous phase, which is the water. And so if we turn on our separating funnel, which one of them is going to come out first? Is it going to be the kerosene or the water? Right, the water. Because remember, the water is going to be at the bottom where there's a outlet, right? Because as we said, the kerosene is less dense, so it's going to float on top, while the water is more dense, so it's going to be at the bottom. All right. You guys are doing very well. Now let's go on to question number 16. Which of the following substances, when added to pure water, significantly increases the water's conductivity? All right. So what's the answer to number 16, guys?
Is it dog?
All right. So we have dog, right? And that's beautiful, right? Sodium chloride. Now, why wouldn't it be A? Why can't it be graphite? Anybody have any ideas for that? Why is it not graphite? All right. So I'm going to explain each of their answers so that next time when we see this, we know for sure why it is sodium chloride, right? Because that's the important thing. You need to be able to know why your answer is correct so that you can be confident about it. Go ahead.
I think, is it because like, graphite, when you put it in water, it's not going to dissolve?
Right. Perfect. It's not going to dissolve. Now, why is it that sodium chloride is going to increase the water's conductivity? What is it that's going to increase the conductivity? The presence of ions, right? And so what we need is something that's going to dissolve and form ions, right, in the water. And so that's why we're talking about sodium chloride, right? Because sodium chloride will form ions, whereas iron hydroxide is not soluble in water either, nor is copper hydroxide. Copper hydroxide is worse, not soluble. And then we also have the graphite, which is not soluble, right? So we need something that is soluble and ionic. And so that would be D as in dog, or sodium chloride. All right. The next question. A solution having a pH of 1 will do what?
B.
All right, so I see B as in boy. Can you tell us why it would be B?
Because a solution of pH of 1 is an acid reacts with a metal to produce salt and hydrogen gas.
Beautiful, beautiful answer, right? So we know that the pH of 1 means it's an acid. And the formula, the general formula, acid plus metal equals salt and hydrogen gas. We're gonna get into it later, but How can we identify hydrogen gas?
It's going to make a squeaky pop sound when you put it like over a lighted splint.
Beautiful. All right, next question. Which of the following halogens is a liquid at room temperature?
Bromine.
Wonderful. But what is the state of the other halogens here at room temperature? Can anyone tell me?
Chlorine and fluorine is a gas and iodine is a solid.
All right, beautiful. Right, so everybody heard that one, right? Iodine is going to be a solid. Fluorine and chlorine are going to be gases, and bromine is going to be a liquid. All right, let's keep going. Number 19. A weak acid is best described as one that yields a what? So this question is asking us, what makes a weak acid a weak acid? So what do you guys think for this one?
D.
C.
Okay, I heard D as in dog. Why?
Because a weak acid has it has less hydrogens than a strong acid.
Okay, that's not bad. What I would say is that a weak acid does not dissociate completely in solution, right? Now, if you think about it, it's not going to be as effective if it can't give up hydrogen ions. So think about it that way. So it's weak because even though you probably put 1 mole of the acid in the water, you're not going to get out 1 mole of hydrogen ions from that acid, right? And so that's why we call it a weak acid, because it's not going to completely give up all of its hydrogen ions like that. Now, anybody know any examples of weak acids? You just have to give me one, just one. Any examples of a weak acid? Anybody know?
Ethanoic acid.
Ethanoic acid, beautiful, right? And actually, not just ethanoic acid, but a lot of our organic acids are weak. All right. Number 20. Which of the following methods may be used in the preparation of barium sulfate in the laboratory?
Precipitation.
Precipitation, beautiful. Why can we use precipitation for barium sulfate though?
Because I think barium sulfate is insoluble, and you use precipitation whenever you want to prepare insoluble salts.
Beautiful, right? So whenever we want to prepare an insoluble salt, we have to use precipitation, right? Or other methods here can be used when our salts are soluble. Distillation, not so much, but crystallization and evaporation, definitely, right? Why? Because at that point, the crystallization and evaporation there, we are getting rid of some of the water, right? So for evaporation, we'll be getting rid of more water than with crystallization, because with crystallization, we form a lattice where water is a part of it, right? But for precipitation, what we want is to get the salt only, that's one, but it has that benefit of being able to make our insoluble salts. right? Because they will not stay in solution, or they will not actually dissolve at all. All right. Number 21. Which two of the following statements describe acid salts? Anybody have any ideas for this one? Which two describe acid salts? So it's either, all right, so we have C, 2 and 3. All right. Yes, our answer is C, 2 and 3. So what are acid salts, guys? Does anyone know?
A salt that contains hydrogen in it.
Right. So essentially it's basically that, right? So a salt that has hydrogen in its anion, right? And this hydrogen can be dissociated out. So here, whenever you replace the hydrogen in that acid salt, then you will form a normal salt. So for example, can anybody give me an example of an acid salt? Any examples, guys, of acid salts?
Sodium hydrogen sulfate.
All right, beautiful. So sodium, hydrogen, sulfate, right? Now, here we have a hydrogen that can be dissociated out. If we were to get rid of this hydrogen, you would have sodium sulfate, which is not an acid salt, right? And so since this is a normal salt, we have proven number 2. Number 3, the anions dissociate to give hydrogen ions. Yes, right? So what would our anion be here? Oh. It would be the hydrogen sulfate ion, right? And so whenever this dissociates, you would get a sulfate ion and a hydrogen ion. Understood? And so that's how we get to prove part 3 as well. So it's 2 and 3 for this answer. Does everybody understand, or do you need me to go over it? You can say it in the chat, or you can say it out loud. Everybody understand?
Yes, miss.
Yes, miss.
All right, awesome. Thank you guys for the feedback. All right. Question 22. In which of the following reactions is sulfur dioxide acting as an oxidizing agent? Any ideas for this one, guys? While you guys think and while you guys are working it out, what is an oxidizing agent? And how can we identify what is an oxidizing agent? Any ideas for what an oxidizing agent is?
Miss, an oxidizing agent causes an element in its free state to lose electrons.
Okay. Yes. Okay. I think that's a good way to put it, because remember, this little help guide, oil rig. Have you guys ever seen that anywhere? Oil rig?
Yes, miss.
Yes.
Right. So we know that oxidation is
Yes, Miss.
loss and reduction is gain. Right? Now, an oxidizing agent is going to cause something to lose electrons, as our friend Rajay just said, right? So here we're looking at sulfur dioxide, and what do we notice here? We're noticing that it's not so easy to see where something is losing electrons, right? Because then we're gonna have to go all the way down and calculate the oxidation state of each of these elements to do that. And what you'll notice with paper ones is that time starts off flies, right? And so we need to know also the other definitions of oxidation or oxidization, right? Now there's another definition of oxidization, which is called what? There's another definition which states that it's when you provide oxygen to something, right? So here, you'll see that in some of these, where sulfur dioxide is actually giving up its oxygen, right? Now, where do we see this happen? We see this happen in B, right? Where sulfur dioxide has given up its oxygens to or hydrogen sulfide, so that we have water and sulfur. So here is where it's acting as an oxidizing agent in its, easiest form to remember it, right? So what you'll notice is that for oxidation and for reduction, there are different definitions. And I want you guys to really look into them because they can help you. They're kind of like, I don't want to say shortcuts for how to get to answers better, but they will help you out in an exam, right? So I just gave you one of them, which is that whenever you're oxidizing something, if oxygen itself is involved, look to see there's a transfer of that oxygen. Whatever transfers the oxygen to the other compound would be your oxidizing agent. So here, B is our answer, because here we see it turn from sulfur dioxide into sulfur because it has given its oxygens to hydrogen sulfide to form water. All right? Does everybody understand?
Yes, miss.
All right, beautiful. All right, we're gonna move to the next question, question 23. 23, in which of the following compounds does hydrogen have a negative oxidation number? All right. So you guys can take your time with this one, right? Because for this one, we're going to have to calculate the oxidation state of hydrogen. So for our first one, what is the oxidative state of hydrogen here in methane?
What do you mean by oxidation state?
All right, that's a really good question, right? So essentially, whenever we're forming bonds, right, what we'll notice is that When we're moving from an atomic form to an ionic form, we either have to gain or lose electrons, right? Now, our charge that we gain, whenever we gain or lose electrons or share electrons, is what is our oxidation state, essentially, right? That's the easiest way to think of an oxidation state. The charge that we gain or lose, right? Now, here, we have a sharing of electrons in A. I hope everybody's with me for A. We have a sharing of electrons for carbon and hydrogen, right? In methane, we have a carbon and we have 4 hydrogens, right? Here, our hydrogen is just H plus, right? How do we know it's H plus in methane? Because remember that for our carbon, it has 4 valence electrons, right? And for our hydrogen, it has 1 valence electron. So in order to satisfy our carbon, we need to have our hydrogens, 4 of our hydrogens, right? Let's move on to the next one, H2O2. We know that oxygen normally has a charge, right? The oxygen ion normally has a charge of 2 minus, right? But in this case, is that true? In hydrogen peroxide, is it true? Any answers, guys? Is it true that in hydrogen peroxide, oxygen has a 2 minus charge?
No, miss.
Right, it does not. Instead, it has what charge? What's the charge on it?
1 minus.
1 minus, right? And so as we said, essentially, for oxidation number or oxidation state is going to be that charge, right? So here we have 1 minus for oxygen, and we have 2 of them, so that is going to give us a totality of 2 oxygens of 1 minus. So that means our hydrogens are going to be 1 plus, and we have 2 of them. So here our hydrogen is just, it has an oxidation state of +1, right? For our ammonia, right? For our ammonia, here we have nitrogen with an oxidation state of -3 and hydrogen with an oxidation state of +1 again. But what do you notice with sodium hydride right here? Sodium is a metal, right? And metals always, in instances like this, they always have oxidation states that are positive. That's where they prefer to be, right? So that means our sodium has a +1 oxidation state. But in order to balance it out though, right? In order to balance out our sodium and our hydrogen, here we have sodium hydride. What do you think the oxidation state or the oxidation number of hydrogen has to be for us to get to an overall charge of 0?
-1.
-1, right? And so that's what this question is asking you. It's asking you, in which of these compounds, methane, hydrogen peroxide, ammonia, sodium hydride, in which of those will we find hydrogen having a negative oxidation number, right? Or a negative oxidation state? And that is D, or sodium hydride, right? Did everybody understand that one? Does anyone need me to go over it? Or can we move to question 4? Question 24, guys. Everybody understood question 23? All right, beautiful. Question 24. When an exothermic reaction occurs, energy is absorbed, released, absorbed from the reactants, released from the products. What's the answer for this one, guys?
Released to the environment.
Released to the environment. Beautiful. All right. Next question. Which of the following observations is expected with the electrolysis of concentrated sodium chloride solution using graphite electrodes? What you guys thinking for 25?
Is it
Pardon me? What was the answer you said? A?
A?
Wonderful. Yes, our answer is A. Now remember, what kind of ions are attracted to our anode?
Negative.
Beautiful, right? Or anions are attracted to our anode. Now in sodium chloride, which of these is our anion? The sodium or the chlorine?
Chlorine.
Right. So this question is asking you, which goes to the anode and what happens at the anode? That's the two things it's asking you, right? So the first answer would be that chlorine goes to the anode because it's the anion here. But what happens at the anode? I don't know if you guys know this little mnemonic, ROCA. Reduction occurs at the cathode and oxidation occurs at the anode. So here we have Cl minus being converted to Cl2. So 2Cl minus to Cl2. That would represent a loss of electrons, right? And so that's what we call oxidation, a loss of electrons to form something, right? So here we're forming our chlorine gas is evolved at the anode. And that's because oxidation occurs there, right? And so that's how we get the answer for 25. Let me know if you guys didn't understand that or want me to repeat, okay? But if there's no one that wants me to repeat, we can move on to question 26. A solution X is added to acidified aqueous potassium iodide, which turns brown. Addition of starch to the solution results in a dark blue coloration. It is possible that solution X contains which of the following?
Fe2 plus ions.
Fe2 plus ions, okay. Tell me why you think so.
It's because the potassium is being displaced, and when the color of Fe2 plus is blue.
All right, but you notice that this one says dark blue, right? And typically, our Fe2 plus kind of has more of a lighter blue color. And then our Fe3 plus has a rusty brown color, right?
Isn't Fe2 plus kind of
Green.
green?
Green, yeah, blue-green. Right, so think of it more of like a blue-green sort of color. And then our Fe3 plus is more like a red-brown sort of color, right? So when you think of it that way, the answer here would not be the Fe2 plus because what do you notice? What causes it to turn the dark blue? Starch, right? So I think here we have to work backwards in order to really see this, right? So let us do a little bit of drawing, right? So here we have a solution of potassium iodide, right? When we add solution X, that potassium iodide starts to turn brown, right? Then when we add starch, we start to see a dark blue starting to form, right? Now, for those of us who remember our food tests, the dark blue is signifying that there is what? What's the dark blue signifying?
Presence of starch.
Right, presence of starch. But if we already know that there is starch and we put that into a solution, what does it signify for the solution? That there is iodine, right? And not iodide, but iodine in its elemental state, right? So it's iodine solution that we have formed, right? Now, if there's iodine solution, right? And at first we had potassium iodide, where iodide is I -1, we are going from I -1 to I 0, right? No charge on it. So when we're going from -1 to 0, what does that look like? Is this oxidation or reduction?
Oxidation.
Right, that's oxidation. Because remember, if we have a charge of -1, that means we have one additional electron, right? And so to get to 0, we have to lose an electron, right? And so since we've lost an electron, then that means the the potassium iodide is oxidized to iodine, which is brown. And then when we add the starch to show the presence of iodine in solution, it turns blue. So the answer here would actually be D as in dog. An oxidizing agent is present in solution X, right? And how do we know that? Because as we said, the first color change, right? Where we change the potassium iodide to a brown solution shows that iodine in its elemental form I0 has been released. Okay? Does everybody understand that one, or do you want me to go over it? Everyone understanding? You guys still with me?
Yes, miss.
All right, awesome. All right, number 27. In which of the following substances will electrolysis not occur when an electrical current is passed through it?
B.
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 All right, good. Why is it B?
Because it only passes through aqueous or molten substances.
It only passes through aqueous or molten ionic substances. So yes, that's why it's B. What will electricity or electrical current pass through in the solid state? Can anyone tell me?
Mobile electrons.
That's not really what I'm looking for. I'm looking for a type of compound or a type of molecule. So just like how you have ionic compounds and you have covalent compounds, you have your giant covalent, you have your metal lattice, these things. Tell me, what kind of compound do you think electrical current will pass through in its solid state?
Metal.
Beautiful, right? So our metals are one example of a compound that electrical current will pass through in the solid state, right? Because when you think about it, you know, we have electric wires. Electric wires are solid. And so how would we get electricity if electricity couldn't pass through them in the solid state, right? So metals are one of those compounds. All right, 28. Which of the following factors will usually increase the rate of catalytic decomposition of hydrogen peroxide?
Increasing the pressure? I mean the temperature.
Beautiful, right? Increasing the temperature. Why would increasing the temperature work though? Can anybody tell me why?
Because temperature is one of the factors that increase the rate of a chemical reaction.
All right, beautiful. That's a good way of explaining it. So remember, temperature is really just a measure of energy, right? That's inside something. Now, what you'll notice when you increase the temperature is that particles of a substance will begin moving more quickly, and so there'll be more collisions. Now, with more collisions taking place, then there's more chances that those collisions are going to be effective in causing a chemical change. And so that's why the chemical, or the reaction rates rather, is increased whenever there's an increase in temperature. All right? Number 29. Which of the following substances is an amphoteric oxide? You guys know this. Amphoteric. Somebody said B as in boy. All right, awesome. You're doing really well, right? So aluminum oxide, what does it mean to be amphoteric, guys? Just as a reminder.
It can react with both acid and bases.
Beautiful, right? All right, after this next one, we're gonna take a short break. So which of the following diagrams best illustrates the course of an exothermic reaction? Let me go so you can see all of them. A, wonderful. But why did you say A?
Because the energy of the reactants are greater than the energy of the products.
Beautiful, right? So that means energy is released, aka it's exothermic. Wonderful. All right, guys. Right now we're gonna take a short 2-minute break. You can shake out your legs, drink some water, whatever you need to do. We've been here for an hour and a half, so we'll be back in 1 minute, well, 2 minutes, as I said. So 11:34. All right, guys. It's now 11:34. So let's get back into it. Question 31. All members of a homologous series have similar what? Densities, chemical properties. Beautiful, right? Chemical properties. So for physical properties, why is it that they don't have the same or similar physical properties? Anybody know? It's okay to say you don't know. Just say you don't know or type you don't know. Or you can type the answer.
Wait, what was the question?
Why don't they have similar physical properties?
I'm not too sure.
That's fine, right? So essentially, the members of a homologous series, we know that they differ by CH2, correct? So if they differ by CH2, that means they're increasing or decreasing in length. And as they increase in length, their physical properties become different because we're talking about organic compounds now, right? And so that as they get bigger and bigger, things start to change. So their state will start to change. So the ones that were smaller were gases, and as we progress to bigger and bigger molecules, these are liquids and solids, right? So essentially that's where we're getting at, right? So as these compounds get bigger and bigger, their physical properties begin to change as they get bigger. But the chemical properties, because of the functional groups, will remain the same. All right? All right, item 32. Item 32 refers to the following graph, which shows the boiling point of some straight chain alcohols. The question asks, which of the following molecular formulae represents the alcohol whose boiling point is 180 degrees Celsius? What do you guys think for this one?
Dog.
Dog. Okay, wonderful, right? Because as we can see, if it's 108 degrees Celsius, where would we be? 1, 2, 3 here, right? And so we would start to extrapolate. And where is that? That's above 7 carbons, right? And so when we get here, it's important now to look to see, okay, where can we find those 7 carbons? So here we have 1, C times 6, 6, 1 plus 6 equals 7. So the answer is D as in dog. Does everybody understand how we got to that answer? If you understand, you can just say yes, or you can react, or you can just type it in the chat. If you don't understand, it's more important. Okay, awesome. It's more important for you to say something if you don't understand, so that we can really just go through it and make sure that you're ready for your exams. All right. Next question. To which homologous series does the following structure belong?
A.
A, beautiful, right? Why you say A though? How did you know that that's the homologous series it belongs to?
Because carboxylic acid has the formula C double bond OA.
Beautiful, right? All right. Now we're on to some nice questions, right? Item number 34 and 35 refer to this chart that we're seeing here, right? So we're starting now with ethene, and one reaction is going from ethene to polyethene. What's that reaction called? Does anyone know? Ethene to polyethene.
Is it esterification?
No, not this time, not this time. It's not esterification this time, but you're on the right track, right? Because we're looking for something that's going to form a polymer, right? So for this one, it would be addition, polymerization, right? Then we have the next one. Ethene is reacting with bromine gas, right? What would be the product formed if we have ethene and bromine coming together? Anyone know? What would be the product formed? Remember, guys, if you don't know, better you say you don't know than you keep quiet, okay?
Yes, I don't.
All right, awesome. That happens sometimes. You just, when you get to something that you don't know, it's important to either say something, or if you're in the exam and you're not too sure, then you can use method of elimination, right? But remember now, ethene looks like this. Whenever you see me draw these sticks, these just mean hydrogen is attached, right? And because it has a double bond, is it saturated or unsaturated? Any ideas, guys? What does a double bond mean? It's saturated or unsaturated? Dania or Dania?
Unsaturated.
Unsaturated, beautiful, right? So whenever we have an unsaturated compound like ethene, what you will find is that it's going to go through an addition reaction whenever we react it with something like halogens, right? Like bromine. So instead of having this double bond, what you'll find is that you'll have a single bond and the attachment of two bromine molecules, right? And so what you'll form is 1,2-dibromo ethane. Okay? So that's what we'll have here. What about here? Ethene, plus water in the presence of an acid, like concentrated sulfuric acid. You guys can give a guess or you can say not sure. Pardon me? You said ethanoic acid?
Yes, miss.
All right, so in this case, instead of ethanoic acid, here what we have is a hydration of ethene, right? And when we hydrate ethene, we form an alcohol, right? And so the only alcohol that we have here is ethanol. So that's what we have for product one. Product one, whenever you see an alkene like ethene reacting with water in the presence of a very strong acid, they're gonna get an alcohol, right? And so the only alcohol we have is ethanol. All right. '35. The product polyethene is what? Is it a gas, a liquid, a solid, or a solution?
Solid.
Yes, it is a solid, right? So remember now that our polyalkenes, right? Or polyalkenes, these are what we use to form things like plastic, right? So whenever we think of a polyethylene or polyvinyl chloride, things like those, PVC, we think of solids, okay? Number 36. Which of the following reactions occurs between propene and bromine? We just talked about this one, guys. Propene, which is an alkene, and bromine. Anyone know this one, or do you have any ideas?
Addition.
All right, guys. So this one would actually be an addition reaction. Because remember, we just said it a while ago here, right? Where when we have a double bond with our alkenes, they go through addition reactions with our halogens like bromine to form a dihaloalkane. Okay. And so the answer for this would be addition, right? Next question. An organic acid and an alcohol come together to form an ester and water. The forward reaction is known as?
Esterification.
Yes, esterification. And what is the reverse reaction known as?
Hydrolysis.
Hydrolysis. Beautiful. 39. When large alkane molecules are cracked, the products are a mixture of what and what? All right, so here we have an answer A, but not sure. All right, that's absolutely fine to not be sure, right? So whenever we have a large alkane molecule being cracked, the product is actually going to be a small alkene and small alkanes, right? So it's D. It's just something to kind of know, right? So just like how we know that whenever we react an acid and a metal, we get a salt and hydrogen, it's kind of like one of those reactions to just try to remember, right? So whenever we crack a large alkane, we get a small alkane and an alkene. All right. Next question. Which of the following reagents can be used for converting ethanol to ethanoic acid? All right, so we have A as one of our answers. Any other ideas for this one? Ethanol to ethanoic acid? All right. So when we're moving from ethanol, which is COH, right, to ethanoic acid, which would be C double bond O OH, what do we notice though, right? What is being added here? Come on, guys, what is being added? If we're going from alcohol to an acid, we see that an oxygen is added. Perfect, right? And if an oxygen is being added, then we need a strong oxidizing agent. And so here, the answer would be C as in cat, acidified dichromate. All right? Next question. The fermentation of sugars using glucose as the substrate can be represented by which equation? A or D? All right. So let's go through it, right? So here now, we have to first be able to identify what is glucose, right? Now glucose is C6H12O6, right? And we see that here on our reactant side for A, B, and C. So that means D would not be in this one, right? Then it says the word fermentation, right? Now, fermentation occurs in anaerobic conditions. Anaerobic, right? Anaerobic means no oxygen. So that means A wouldn't be it either, right? All right, so Dania says C. All right. So here our answer would be C. But how do we get to C? Or how do we know it's C? Fermentation is used to form alcohols, right? And so here we have glucose being used to form ethanol. And so the answer would be C as in cat. All right. Number 42. Glucose is converted to starch or cellulose by which process? So remember we went through this before. So which process do we use to convert starch or cellulose? Sorry, to convert glucose to starch or cellulose.
Reduction.
Oxidation and reduction. All right. So for this one, the answer would be D as in dog, right? Condensation, polymerization. And I think this one can be a little bit unfair in the sense that if you do biology, you have more of an advantage answering this question. But don't worry, we're going to clear it up now so that if you see it again, you will know that it's going to be condensation, polymerization. Now, what is condensation, polymerization? This is when we have two molecules coming together and there is an elimination of a small molecule after these come together. So an example of this would be esterification, right? When we have ethanoic acid and ethanol coming together, which small molecule is released? Anybody know? Which small molecule is released, guys? Whenever we form an ester. Let me see if I can find back the question so that you can see it. When we are forming an ester, let me just go down to it and we'll answer it together then. When we are forming an ester, what you'll notice is that when we add the ethanoic acid to the alcohol, right? What we'll find is that the hydroxide on the ethanoic acid is removed, as well as the hydrogen on the ethanol, right? And so what you'll find is that you have H plus OH minus. What does that give you guys? H plus OH minus?
Water.
Water, right? That gives us water. And so in condensation, polymerization, when two things come together, right, you'll have the loss of a small molecule like water. And this happens a lot in our bodies, right? So for example, whenever we have two amino acids coming together, then we will have the loss of NH3. right? And so essentially that's kind of what we're getting at. What we're getting at is that whenever these two molecules are coming together to form a polymer, then we're going to be losing a small molecule, right? And here it would be water. Now, in the formation of starch or cellulose, we have glucose, which has a similar setup at the ends, right, to this. Not exactly the same, but very similar. And what you'll notice is that water is released. And so that's why D here is condensation polymerization. All right. Number 43. Which of the following features belongs to metals? We're almost finished this paper, guys. Which one of the following features belongs to metals? Any ideas?
C.
All right, so I'm hearing C. Anybody else? Any other answers, guys? So we heard C. All right, let's go through it together. All right, so when a metal joins together with chlorine to form a chloride, right? For example, sodium chloride, we get a nice salt, right? And this salt is a solid chloride. So that means one has to be in it, right? So that means C would be out just based on the fact that one has to be there. Then forms basic oxides. Yes, that is true, which means B would be out. But then that would come down to part 3. Okay. All right. And that would come down to part 3. They conduct electricity when molten. All right, so this one, it can trip you up to think that it is A because it says when molten, but it doesn't say only, right? Metals will conduct electricity when they're molten and when they're solid, right? And so in essence, what this is asking you to do is to identify which of these is true, right? And so 1, 2, and 3 are true, right? So if you were to put A, you'd get it wrong because you would have left out number 3, right? And this says 1 and 2 only. All right. Number 44, guys, almost through. Which of the following processes produces a gas which is different from the others? I want you guys to start thinking about it. Which of them produces a gas which is different from the others?
B.
B as in boy. All right, wonderful. That's
Yes.
a really amazing job, right? So remember, respiration in animals produces carbon dioxide. Photosynthesis in plants produces which gas, guys?
O2.
O2, right? Heating of calcium carbonate. What does that produce?
Carbon dioxide.
All right, CO2. And then oxidation of carbon monoxide. What does that produce?
Carbon dioxide.
Beautiful, right? Now, We can move on now to question number 45. Which of the following metals will not displace hydrogen from dilute hydrochloric acid?
C.
C as in cat, beautiful, and why?
Because copper is below hydrogen, so it cannot displace it.
Beautiful, right? Number 46. Which of the following methods is used for the extraction of aluminum? Which one of them is used for the extraction of aluminum, guys? All right. Any guesses? You can guess, you can genuinely answer, you
C.
can just say don't know. So I heard C as in cat. All right.
Is it?
Yes, right. So it's A, electrolysis of the molten oxide. So remember C now, C is different. C is iron, right? But aluminum is electrolysis of its molten oxide. Which of the following statements about sulfur are true? Now you may not know all of these, right? May not know all of these. But which one of these can you rule out based on what you do know? All right. Anybody know which one can we rule out of 1, 2, and 3 based on what we know?
3.
All right. So I see somebody said 1, someone else said 3. All right. So that means, guys, you need to review extraction of metals from their ores, right? Because remember, for iron, we don't use sulfur in extracting it from its ore. So even if you didn't know if it was 1 or if it was 3, you have to remember that the raw materials used for iron do not include sulfur, right? And so anything with 2 would be gone, leaving you with just B as in boy. Because sulfur is used in the vulcanization of rubber, that's true, and it's also used in the manufacturing of explosives. All right, so that's exactly why I spoke to which one you could rule out, because if you were able to rule out that one, then you would get the answer immediately, right? So you just have to kind of remember or learn how to use, method of elimination to help you out sometimes. All right, and we're gonna get to more questions that kind of have that same vibe. So don't feel defeated, right? Because the exam is a little ways away, so you can definitely, get everything you need to get done before then. All right. 48. Which of the following substances conducts an electric current but remains chemically unchanged? Anybody have any answers to this one? All right, so we have somebody said B as in boy, and you are correct. It is B, copper, right? Copper is a metal, right? And so metals, what you'll notice is that they remain chemically unchanged whenever they conduct electric currents. Remember now, sulfur does not conduct electric current, so that one is just the one to kind of throw you off. But A and D, right? when you think about electrolysis and what happens, right, in electrolysis, it would tell you that whenever there is a solution, right, that conducts electric current, it will be chemically changed, right? And so that's why we're going with 48, or with B for copper for 48, because copper, which is a metal, will remain chemically unchanged after an electric current is passed through it. All right. Question number 49. Which of the following gases is not considered to be toxic? Not considered to be toxic, guys. Any ideas for this one, guys? Number 49. Remember, it's okay to say you don't know. All right, so we have C. Anybody else? All right, we have A, right. So the answer today for number 49 is A, actually. Carbon dioxide. Carbon monoxide is highly toxic, so is nitrogen dioxide. Sulfur dioxide is also toxic, but carbon dioxide is not, it's completely non-toxic, it's just minimally toxic, right? So that means our bodies can withstand a large amount of carbon dioxide without anything really happening to us that's overtly negative or that can cause death, right? So when we compare it to the others, then carbon dioxide is the least, or rather most negligibly toxic. All right. Number 50. The compound which has the formula CH3, C double bond CH, CH2, CH2, CH3, as you can see here, is what? An alkene, an unsaturated acid, a carboxylic acid, or a polymer?
An alkene.
An alkene, beautiful. And how we know it's an alkene?
Because of the double bond.
Because of the double bond, wonderful. Number 51. When copper 2 carbonate is heated alone in a dry test tube, a gas is evolved and a black residue is formed. The gas is expected to do what? Turn red litmus paper blue, relight a glowing splint, decolorize acidified aqueous potassium manganate 7, or form a white precipitate with aqueous calcium hydroxide.
B.
Beautiful, right? Which gas is that?
Carbon dioxide.
Wonderful, right? Next question, number 52 is related to these setups, right? So let me make it larger so you can see what the question is going to ask about it. In which experiment would the amount of chlorine collected be greatest? Any ideas, guys? Remember, you can type it in the chat or you can say it out loud. All right, so somebody says D as in dog, 4. Any other answers or guesses? All right. So what I can tell you is that you're definitely on the right track for this one, right? So number 4 has the heat to help increase the rate of reaction, right? It also has the reactants, they're concentrated. What's the difference between number 1 and number 4 though? Can anybody tell me the difference between number 1 and number 4?
The position of the gas syringe.
Right, the position of the syringe. Now, what do you notice about it? One is going with gravity, so that's down, and one is going against gravity, that's up, right? Now, that would be dependent on the density of your gas, right? So can someone tell me, is chlorine gas more dense or less dense than air? Any guesses, guys? Is chlorine gas more dense or less dense than air?
Less dense.
Actually, chlorine gas is more dense, right? And so because it's more dense, it's going to sink. And so essentially, the answer for this question would be A, right? Number 1 would be the answer. Why? Because the relative density of chlorine would cause chlorine to be better collected downwards than upwards, right? Because it wouldn't want, if its density is high or too high, it wouldn't want to travel up that tube going all the way up through to the air syringe or to the gas syringe, right? So essentially, what would happen is that it would have just a small distance to travel against gravity in number 1, and then it can be collected properly downwards at the end. All right, so we're going with with A, which is number 1 for 52. 53. Which of the following observations is expected when aqueous silver nitrate is added to aqueous potassium chloride? What do you guys think? Any ideas?
So I'm not sure what to
What did you say?
say.
All right, so you said A, a pungent gas is evolved. All right. So what I want us to focus on here now is, if silver nitrate is added to potassium chloride, right? What's going to happen? Well, when the silver nitrate is added, the potassium is going to displace the silver, right, ions from the nitrate, and that would leave them to do what? To bond with or to bind with the chloride ions, right? And as we know, silver chloride is insoluble, and so it forms a precipitate, right? And that precipitate is a white precipitate, so that is C as in cat, all right? We're almost finished with this paper, guys. Question number 54. A particular metal may be selected more than once or not at all. So here we have aluminum, copper, iron, and sodium, right? So 54 is asking us which metal reacts vigorously with water to produce a strongly alkaline solution. What do you guys think for this one?
Sodium.
Sodium, beautiful, right? And why you say sodium?
Because it's in group 1 and group 1 metals react vigorously with water.
All right, that's not a bad. That's really not a bad answer at all, right? So it's not really that all of group 1 does that, but essentially that sodium is a very reactive metal. Basically, all on its own, it's very reactive, right? We know that we have to store sodium outside of the contact with air, right? Because it's so reactive. So essentially, it reacts vigorously with water, which is something that we just proved, right? But it produces a strongly alkaline solution. Sodium hydroxide will be produced. And as we know, sodium hydroxide is a strong base, like very strong, right? So that's correct. 54 is D as in dog. What about 55? Which metal has an alloy which is used in the manufacturing of aircrafts?
A.
Yeah.
A? All right, beautiful. Anybody know the name of that alloy?
Duralumin.
Is it
Duralumin?
Duralumin. I'm not sure.
All right, all right. It's one of the alloys, so I'll give you a point for that, definitely. Right? So when we get back to it, because we're gonna see it again, what you'll notice with the paper ones is that there's a lot of repeats. When we get back to it, we're gonna go over it again and you're gonna see it, right? Because I have it written down a little bit lower. All right. 56, a gas Z, right, has physical and chemical properties similar to ammonia, right? The best method for collecting a pure dry sample of Z would be to pass it through what? Ideas, guys? All right. So let me tell you guys, right? So for 56, the answer would be B as in boy. If you pass it through calcium hydroxide, it will dry it, right? Because calcium oxide is a drying agent, right? So what it would do is that it would dry it out and it collect it by upward delivery because ammonia has a relative density that is lower than 1, which means that it is lighter than air. So remember that question that we had a while ago with these setups? Remember this? This is how you collect it, right? Collect it upwards because its density is lighter than, well, is less than air. So it'd be lighter than air. Therefore, it collects it upwards, right? Number 57. The main substances responsible are main substances responsible for acid rain, guys. Same boy. I think somebody was trying to unmute their mic. Go ahead.
Is it C?
Yeah. Well, no, actually, it is D as in dog, right? All right. So I see a lot of A, right? All right. So let's go through it a little bit because I think there may be a little bit of a misconception, right? So remember, acid rain, primarily, sulfurous acid, right? Those two are mainly what you find in acid rain, right? But then also, for those people who said A, remember that the chlorofluorocarbons, those are the ones that contribute to the depletion of the ozone layer, right? So those are not the ones responsible for acid rain. B, lead compounds in exhaust fumes. Those are actually responsible for things like respiratory distress, right? We don't really hear about them too much in acid rain at all. Carbon dioxide and carbon monoxide, these are greenhouse gases. And while carbon dioxide can dissolve in water to, make it acidic and stuff, you have to remember that the sea is a big sink for carbon dioxide, right? So it's more likely that the carbon dioxide is going to be dissolved in the seawater and cause erosion of the shells of the sea animals and erosion of our coral reefs than it is that it's going to cause acid rain, right? So essentially the answer is D here, because we know that sulfur dioxide is going to form sulfuric acid and sulfur trioxide is going to form, sulfur dioxide is going to form sulfurous acid and sulfur trioxide is going to form sulfuric acid. Okay? I hope everybody understands. Remember to tell me if you don't understand, okay? Now on to question 58. Although aluminum is more reactive than iron, aluminum becomes corrosion resistant when left exposed to the atmosphere, while iron will corrode. Why is this so? That's what the question is asking us. Why is that so? Any answers, guys? Remember, guys, this is the first paper that we're going through, right? So we haven't met up on anything that we can, say, oh, we've repeated and we've seen this before yet. So don't feel any way about that, right? So if you don't know, you just say you don't know, right? All right, no problem. So remember now, aluminum, whenever aluminum is left out to the atmosphere, it'll form aluminum oxide, right? And hydroxide if it's left out to, the elements and you get water involved, all of that, right? The same thing will happen to iron. But with iron, what you'll find is that you'll have rusting taking place, but with aluminum, there's no rusting. And that's because the oxide film that's on aluminum is protective, right? It prevents any more reaction taking place with the layers underneath it. Whereas the iron oxide, it does not protect the surface, right? It is penetrable. So essentially the answer here would be C, because the oxide film on the aluminum is protective, whereas the oxide film on the iron is not protective, okay? Number 59. Which of the following substances is an important constituent of chlorophyll? Does anyone know this one?
Magnesium.
Magnesium, beautiful, right? And then question 60. Which of the following gases will give a positive test with dry cobalt chloride paper? Any ideas, guys, for number 60? All right, not sure? No problem. So remember now, with cobalt chloride paper, and it's the same thing with copper sulfate paper, or paper that has been, dipped in copper sulfate, allowed to dry, etc. These are positive tests, or these will give a positive test with water or steam, right? Because water causes a color change. With our cobalt chloride paper, we have a change, and with our copper sulfate one, we also have a change. For copper sulfate, it is from white to blue. And for our cobalt chloride, to test the presence of water, we know that it's going to go from blue to pink, okay? So whenever you see cobalt chloride paper, you're going to think, okay, we're starting from blue, and in the presence of water, we're going to turn pink, right? But if we see copper sulfate, we're going to start at white, and we're going to be turning blue, all right? So that's the end of our first paper. That paper was 2015. Are you guys ready for 2016? Or do you guys need a little break before we continue? Yeah? You ready to go to 2016, or you need a break? All right. So I guess that means we can go on to 2016. This one should be a little bit faster to go through since we have seen some of the questions already. So it's really just at this point trying to recall what you learned in class, but then also what you may remember from papers that you go through, right? So the first question asks, which of the following processes suggest that matter is made up of minute particles?
Diffusion.
Diffusion, beautiful. Next question. The arrangement of electrons in atoms of X and Y are 285 and 286 respectively. Which of the following represents X and Y?
B.
Did you say B as in boy or D as in dog?
B as in boy.
Beautiful, right? Because as we know, if the valence number is 5 or 6, we're in non-metal territory, right? Next question. Item 3 refers to the following table, which gives the melting point and boiling points of chlorides of 4 different elements. Which of the following elements which of these elements forms a chloride that is ionic in nature?
C.
C as in cat, how do we know?
Because ionic compounds have very high boiling points.
Beautiful. So the answer here is C as in cat. Next question. Number 4. Which of the following statements best describes the difference between an atom and an ion? Any ideas for this one, guys?
D as in dog.
D as in dog. Beautiful. All right. Number 5. Let me just that out. So an atom, question 5 says, which of the following features are true about the arrangement of electrons, protons, and neutrons in an atom?
D as in dog.
Mm.
All right. So we heard the nucleus. Number 3 says, can you guys hear me now?
Yes, miss.
All right, awesome. So we said that 1 is true, 3 is 2. True. But what about 2? Can electrons be found anywhere outside the nucleus? Or are there specific places where electrons are to be found?
On the show.
Miss, they're supposed to be found on the shell surrounding the nucleus.
Right, that's true. At this level, that's what you guys were taught, right? That the electrons are found in their energy levels. And so for this one, I would go with 1 and 3, right? Just based on what you guys were taught, that your electrons are found in your energy levels outside of the nucleus, right? So for this one, I'm gonna go with 1 and 3, which is B as in boy, all right?
Okay, miss.
All right, awesome. For number 6, the mass number of an element is a number of what?
C.
All right, beautiful. C, neutrons and the protons in the atom of the element. Wonderful. Next question. Number 7. Remember, we saw this one, right? Sodium 24 and 23 are isotopes, but why are they isotopes?
D.
D as in dog, right? They have the same number of protons. What's different in sodium 24 and 23?
The mass number for sodium 24 is 29. The mass number for sodium 23 is 22. Mass number is different.
Okay, wonderful. But why is the mass number different? We just said that the mass number is the number of protons and neutrons, right? So if the number of protons is the same, then that means the number of neutrons are different, right? And that's why the mass number is different. Everybody understands?
Yes, miss.
All right, awesome. Number 8, the disadvantage of using a soapless detergent is that what?
B.
B as in boy, you said, or D as in dog?
B as in boy.
All right. Now, actually, soapless detergents do not cause scum. And that's why people use them, right? That's why they're used, because they don't cause scum. Because essentially, if you wanted to be able to use a soapy detergent without having scum, you'd have to make sure that the water is not hard water, right? And that would involve changing up the entire water system, whereas the alternative to that would be to use a detergent that does not have any soap in it, right? So it's a soapless detergent so that there's no scum, right? So it would not be B as in boy, but as we just said, it is not affected by hard water, and that's an advantage, not a disadvantage. So we're going to X that one out as well. It being used widely in industries is not a disadvantage either. D is a disadvantage, however, that is non-biodegradable, right? Now, we said you have to basically look carefully, right? It says disadvantage, not advantage, right? So it's non-biodegradable. So what does that mean for us though? If it's non-biodegradable, then what will happen?
It can pollute the environment.
Right? It can hurt the environment. And that's not what we're looking for, right? We want something that's not going to hurt the environment. All right. So next question. Which of the following aqueous solutions contains 1 mole of hydrogen ions?
D as in dog.
All right, said D as in dog. All right. Any more answers for this one before we, tell the answer? Any more answers, guys, for number 9?
D as in dog.
All right, so we have 2 D as in dog. All right. So we have to look carefully. This one says aqueous solutions, right? And I know that the numbers are going to make you think that this is 1 mole, but it's not 1 mole because of the type of acid that we have here. What kind of acid is this? What's the name of this acid?
Ethanoic acid.
Ethanoic acid, right? Now, ethanoic acid, is it a strong acid or a weak acid?
Weak.
Right, it's a weak acid. Now, what is a weak acid? Remember, we said a weak acid is one that does not completely dissociate, right? So I remember I gave this example that means even if you use 1 mole of the acid, you're not going to get 1 mole of the ions coming out because it will not completely give up all of its ions. So instead, we have to look at our other options because this one is too weak of an acid to give us the amount of ions that we want. Right, but that's a very good try, right? So I'm glad you guys did not choose any of these because as you know, this would produce 2. And by method of elimination, we could choose A, but let's calculate it, right? So remember, the number of moles is equal to the concentration multiplied by the volume. 0.5 multiplied by 2 to give 1, right? 1 mole. And so that's how we can confirm that A is the answer. And why did we choose A over D? Because A is a strong acid, right? And with a strong acid, what you'll find is that it gives up all of its hydrogen ions, right? In solution. Did anybody not understand that, or does anyone want me to go over that just to solidify it for you? All right. Number 10. Which of the following pairs of atoms has the same number of neutrons?
B as in boy.
You guys said B as in boy?
Yes.
Beautiful, beautiful, beautiful. Why did you say B as in boy though?
Because, well, I subtracted the 50 16 from the 31 and I got 16, and then I subtracted the 16 from the 32 and I got 16. So,
Beautiful, right? And we know that the 31 and the 32 are mass numbers, and the 15 and the 16 are atomic numbers or proton numbers. So that leaves us with neutron numbers, right? As our answer. So wonderful. All right, number 11. From which of the following substances can a solid be obtained by the process of sedimentation?
D as in dog.
D as in dog. Any ideas as to why or no? Are you hearing me better now?
Yes.
Suspension. All right. So the reason why, oh no. All right, one moment, guys. Are you hearing? All right, guys, are you hearing me now?
Yes.
Okay, awesome, right? So I was asking, why is it that we can get the solid from a suspension via sedimentation or using sedimentation? Anybody know?
No, miss.
All right. So it's because,
Because particles of the suspension.
all right, I didn't hear you too well, Brianna. But essentially, it's because in a suspension, the particles are very big, right? And so they won't dissolve in to make a solution, and they won't emulsify, nor will they, be able to be light enough so that even if they don't dissolve, they can form a colloid, right? So because they're so big and dense, they sink, right? And so because they sink, we can use sedimentation, which is just that process of waiting while they sink or waiting for them to sink, and then removing what's on the bottom at the end of the period of time. We can use that to get the solid. All right. Question number 12. Ionic bond formation results from which of the following?
A.
All right. Donation of electrons from a metal to a non-metal to achieve stability. Beautiful. Right? Next question. Number 13. Which of the following statements describes the effect of temperature on the solubility of solids in water?
C as in cat.
All right, beautiful. As temperature decreases, solubility decreases, right? And so this also has to do with, you know, the amount of collisions that's taking place. But yes, right? As temperature decreases, solubility decreases. 14. Which of the following statements best describes the formation of a metallic bond? Any ideas for this one, guys?
Dog.
C as in dog, beautiful, right? Cations which are held together by a sea of mobile electrons. Number 15, barium is below calcium in group 2 of the periodic table. When these metals react with water, the main difference in observation is
Rate of reaction.
beautiful, the rate of reaction, right? Because we know that the calcium is going to be more reactive with the water than the barium, right? All right. Next question. I know, man, the color of the product would be the same. Covalent compounds can be formed between which pair?
C.
C as in cat. All
Yeah.
right. Why did you say C though?
Because covalent compounds are formed between two nonmetals, and it would be excluding the noble gases because noble gases don't react with anything because they're already stable.
Right. But how do noble gases exist? Do they exist as, for example, Ne alone, or are they Ne2? Let me know. How do noble gases exist? Do they exist as a compound or as an atom itself or as an element?
Compound.
All right, so if they exist as a compound, right? If they exist as Ne2 or Xe2 or whatever, then why would we say that excludes them? That's if that's true.
Wait, I don't think they're compounds because since they already have 8 electrons, they don't need to make a compound with anything.
Right, right? So we're gonna go with C for this one, okay? So that's the important thing. When you're faced with a question, it's important to really just step back and try to understand it fully, right? Because if you say that the noble gases exist as a compound, then you'd have to include them in having that ability to form covalent compounds, right? But if they do not exist that way, then what? Then they would be excluded, all right? Next question. Item 17 and 18 refer to the following sets into which elements may be placed. So we have group 1, group 2, the halogens, and period 3. Which set of elements forms molecules which contain 2 atoms? Any ideas, guys? So I have
The
someone,
halogens.
the halogens. Beautiful. All right. What about 18? Which set of elements has atoms with 2 electrons in their outer shell?
B.
B as in boy. All right, wonderful. Number 19, a solution has a pH of 1. This solution would be expected to react with
A.
pardon me, you said A. All right, you are correct. A, right? So remember we said that the pH of 1 means it's acidic and acids and metals join together to form a salt and hydrogen gas. All right, next question. Which of the following trends would be observed in moving from left to right across period 3 of the periodic table? Any ideas for number 20, guys?
I'm eliminating B and D
Okay, why?
because I says the melting points increase and it's going from metals to non-metals, so it wouldn't increase. And so I just eliminated the ones that had I in
Beautiful.
it.
Mm-hmm. All right, good start. So what does that goes with? That leaves us with 2 and 3, right?
Yeah.
Right. Now, now 2 is correct, I'll tell you that. And as we move towards the halogens, right, we become more and more acidic. And finally, the elements become more electronegative. That is also true. So C is our answer for 20, okay? 21. Which of the following terms best describes the oxide of a metal? Any ideas for this one, guys? Any ideas? All right. So for this one, the answer is B as in boy. The oxides of metals are basic in nature, right? 22. Which of the following techniques may be used to separate a mixture of plant pigments into their individual components? We have A, centrifugation, B, solvent extraction, C, fractional distillation, and D, paper chromatography.
B as in
B as in dog, paper chromatography, beautiful. 23. In the electrolysis of aqueous copper 2 sulfate solution using copper electrodes, what happens to the anode? Does it decrease in mass? Does it increase in mass? Does it undergo no change in mass? Or is this the site where reduction occurs?
A.
A, it decreases in mass. That's beautiful, right? Number 24. The equation for the reaction of silicon with chlorine is what? Is this, right? Now, in this reaction, silicon is the reducing agent and is what? What happens to silicon here? All right. No ideas for this one? Not a problem. All right, so we have A. Okay, great. So how do we know that? In its elemental state, silicon has a oxidation state of 0, right? That's how it is with all elements. So it's also 0 here for chlorine, right? But what happens is that the silicon reduces the chlorine from 0 to -1. So that's the oxidation state of chlorine here, -1. But as it reduces the chlorines oxidize the silicon. So the silicon is now Si4 plus. Understood? All right. Number 25. The only giant atomic structure that can conduct electricity is
Copper.
copper. Any other answers for this one?
graphite.
Right. So the reason why the answer for this is graphite and not copper here is because they asked for a giant atomic structure, right? Now, metals are not considered necessarily as giant atomic structures. That's the only reason why we have graphite here, right? Graphite is a giant atomic. So is diamond, by the way, right? So it's really just the nomenclature here that would make graphite our answer, all right? Number 26. 2.32 grams of an oxide of iron were heated in dry hydrogen. When the reaction was completed, 1.6 grams of iron were formed. The oxide of iron was reduced, oxidized, neutralized, or decomposed. So for this question, how we tackle it is that if there's an oxide of iron, we're gonna just, write down a simple oxide of iron, right? So FeO, right? So this would be iron 2 oxide, right? And so we're saying that when we heat this up in dry hydrogen, then it becomes Fe, solid, right? As you can see. So if we're moving from Fe2 plus, to Fe0, then that would be a reduction, right? So here, the oxide of iron is reduced. Which of the following energy changes occurs during the breaking of a chemical bond? So when that bond is broken, what happens? Any ideas? No ideas, guys? What happens when you break a chemical bond?
Energy is released.
Energy is released. So we have 2 A's so far. Any other answers? All right, guys, so the answer for this one would actually be that energy is required, right? So energy is required to break bonds, right? But so think about it this way. When you're breaking a bond, we're going from a more stable state to a less stable state, right? And so whenever that is happening, we need a lot of energy to overcome, right, the bond that's there. But whenever we're making a bond, right, we're going from a less stable state to a more stable state. And when something is less stable, it has more energy. So when we're making a bond or forming a bond, then the bond that is formed is going to be of lower energy. And that's why it's easier to form, right? And so when you're making a bond, then energy is released. But when you're breaking a bond, then energy is required. Does everybody understand that one? All right, awesome. Which of the following factors does not determine if a particular cation would be discharged during electrolysis? I want you guys to think about this one. Which of the following factors does not determine if a particular cation will be discharged during electrolysis?
C.
C as in cat. This has a contribution, like the type of the electrode, the concentration of the ion in solution, and the position of that ion on the electrochemical series. So you are 100% correct. It's C. 29. In the following diagram, X represents the symbol of a positive ion. Which of the following pairs represents the number of neutrons and electrons in X?
A.
A, wonderful, right? And how we got A is this, right? So the number of neutrons is going to remain the same because, as we know, it'd be 40 minus 20 to give us 20 neutrons, right? But since it's an ion and we have 20 protons, right? So we have 20 protons, which means that the atom would have 20 electrons, right? But then it lost 2 of those electrons, so it's 18 electrons that's left because it's a +2 charge, right? So that's how we get A. Question 30, we're halfway through this paper, guys. Which of the following oxides react with both acids and bases?
C.
C, wonderful. And what is it called when an oxide or a compound reacts with both acids and bases?
Amphoteric.
Amphoteric, beautiful. All right, question number 31. Which one of the following statements about electrolysis is not correct? Is it that electrons leave the solution via the positive electrode? Is it that electrons enter the solution via the negative electrode? Is it that decomposition of the electrolyte at the electrode produces an electric current? Or is it that decomposition of the electrolyte at the electrode is due to an electric current? All right, do you have any ideas for this one? All right, so for this one, the answer would be C as in cat. So essentially, what it's saying is that in electrolysis, the electric current causes a chemical change and not vice versa, right? That's what D is saying here. Any questions about 31? Or does everybody understand? All right, no questions, so we can move forward. Which of the following statements are true of metals, right? Which of these are true about metals?
D.
All right, so we saw a question like this last time, right? I remember we said that in the last one, I didn't have the word only. But what do you see here for 3? We see the word only, don't we? Right? So for here now, for this question, it would be A. And why? Because in part 3, they said here, they conduct electrons when molten. Now, if only was not there, it would be 1, 2, and 3. But because it says only when molten, then it has to only just be 1 and 2. All right. So remember last time we said it didn't say only, so we could accept it. But because it says only here, that's why we can't accept part 3 as being something true about metals. Okay. All right, number 33. Which of the following is a list of all the raw materials used in the extraction of iron?
I think it's B.
All right, so you think it's B as in boy?
Yeah.
All right. It's not B because of one thing that's here that should not be here. And that is cryolite. Cryolite is not used in the extraction of iron, right? It is instead used in a different extraction. Which one is that? Anybody know? Cryolite is instead used in a different extraction, guys. Come on, do you guys know anything about aluminum extraction? Right, so the answer here would be C, air, coke, iron ore, and limestone. Light is used in the extraction of aluminum. We did something like this. 34.
C.
C as in cap, beautiful. Electrolysis of the oxide in the molten state. Number 35. Which of the following pairs of reagents will result in the formation of a yellow precipitate?
A.
A, wonderful, right? And that's because of this lid right here. In the presence of potassium. Number 36, you guys hearing me?
Yes, miss.
Okay, awesome. So for number 36, it says the ability of an atom to form a cation increases how? Across a period, as the oxidation state increases, as electronegativity increases, or as electropositivity increases. All right, I see D. Perfect. Right? As electropositivity increases, the ability of an atom to form a cation will increase, all right? That's essentially what it is, right? Now, number 37. Which of the following procedures can be used to identify ammonia gas? Any ideas?
D.
D as in dog.
Yes, miss. Beautiful, right? So when we place
All right, guys. So sorry about that. I think something went down, but I'm gonna reshare my screen so that you guys can, so we can continue. All right, guys. So as I was saying, hopefully you're hearing me now. As I was saying, what would you expect to see if we had ammonia gas coming in contact with red litmus paper and blue litmus paper? What would we see? All right. So what you'd see is that because ammonia is a basic gas, right? The red litmus paper would become blue in color, right? And the blue litmus paper would remain the same, all right? All right. Number 38. So 38 refers to the following sequence of reactions involving iron compounds, right? So they're saying, in which stage is the oxidation state of iron increased? Hey guys, remember, if you don't know or you don't remember how to do this, just let me know so that I can like walk you through it. But I won't know if you guys don't tell me.
Miss, I don't remember how to do this.
Oh, okay, no problem. Let me walk you through it, right? So remember that how oxidation states work is that if a substance is in its elemental state, like oxygen gas or iron as it is, its oxidation state is going to be 0, right? If an element is in a compound, right, then its oxidation state is going to be equal to the charge that it gains or the electrons that it's supplying. So for example, if we have FeCO3, right? Here we know that the carbonate ion has a charge of 2 minus, right? Overall, iron carbonate does not have a charge. So if we have 2 minus, if we have 2 minus or -2 plus X, which is what we're going to say is for Fe, and that's supposed to equal to 0, then X, which is the oxidation state of the iron, is going to be 0 plus 2 to be +2, right? Or to come up to +2. So here we see iron having a state, an oxidation state of +2. That's the same thing here. It's still +2 because we know that oxygen here has a state of -2. But as we get to iron 3 oxide, we're seeing that it's now +3. So that would mean that at stage 2 or B is where we have an increase in the oxidation state of iron, okay? Please let me know if you need me to go a little bit more in depth with it or if you're okay with it now. All right. Which of the following aqueous solutions will produce a blue precipitate with aqueous sodium hydroxide?
Copper nitrate, copper 2 nitrate.
All right, beautiful, right? And we know that that's because of this copper 2, right? Whenever we have iron 2, what's the expected color?
Green.
Right, green. Whenever we have iron 3, what's the expected color?
Red brown.
Red brown. Beautiful. You guys already need to know aluminum, but yeah, these are the 3 major ones that you need to know right now. That'd be iron 2, iron 3, copper. Can I think of any more that you need to know? Not quite. All right. Question number 40. Potassium is a metal. From this information only, it may be deduced that potassium is soft, reactive, has a low melting point, or is a good conductor of electricity.
B.
All right, so we said D as in dog or B as in boy?
B as in boy.
All right. What if they were to ask the same question using a different metal, like strontium? So they were to say strontium is a metal. From this information only, it may be deduced that strontium is soft, reactive, has a low melting point, or is a good conductor of electricity.
Then it will be C.
Not quite. Instead, it would be D as in dog, right? And the reason why is because they just use potassium as a filler, right? So the answer here also would be D as in dog, because it doesn't matter which metal that they put there. They're just asking you, if something is a metal, then what does it mean? Are all metals soft? No. Are all metals really reactive? No. We have our silver, we have our gold, we have our copper, right? Do all metals have a low melting point? No. We have those that do have a low melting point, like our mercury, like our gallium. Then we also have those that have very, very high melting points, right? So it's important then to look at something that's common to all metals, and that is that they're good conductors of electricity. They're also good conductors of heat, right? So these are the things that they want you to really be able to pick out, right? The answer is D as in dog. All right, 41. All right, let's look at our table, right? So now they're asking 41, which of the metals is likely to form a soluble hydroxide? A soluble hydroxide. So from that, we can look at the reactions with water and steam. Can also look at the products formed when the nitrate is heated. And it can give us some, hints into what we're looking at. It probably won't tell us exactly which metal, but it will tell us about basically a basic group of metals that we're talking about, right? So does anybody have any ideas for this one before I start breaking it down a bit? Any ideas at all, guys? They're just talking about the different reactivities of our metals, right? Now, if you guys remember, we have our very reactive metals, and then we have those that are not as reactive, and right? And we know that those are organized in our reactivity series, right? So from what we're seeing here in our reaction with water or steam, which of these appears to be the most reactive metal out of W, X, Y, and Z based on their reaction with water?
Why?
Most and our least reactive one would be W, right? Because there's no reaction whatsoever. And so if you were to, go back and read through, you'd recognize that, okay, what we're looking at is a deconstructed sort of reactivity series, right? Where Y is the most reactive, and the information that we have here would suggest that we're looking at either potassium or sodium, right? Because they react rapidly with cold water. And when they decompose, they form the nitrite and the oxygen when the nitrate decomposes. X is no. Z would be next, right? For most reactive. And this one kind of corresponds more so with calcium and magnesium, because here is where we have it reacting slowly with cold water. But when it decomposes to form an oxide. The nitrate decomposes to form an oxide, nitrogen dioxide, and oxygen. Next most reactive would be X, right? And this corresponds to aluminum, zinc, or even iron, right? And so this, let me start writing the min right here so you can see what I'm talking about, right? So this corresponds with aluminum, zinc, or even iron, right? Because as we can see, it reacts with the steam, but not with cold water, which means it's a lot less reactive than this or this. And when it decomposes, when the nitrate decomposes, we get an oxide, nitrogen dioxide, and oxygen, right? And then for least reactive, which is where we're going to be finding stuff like our silver, right? That's where we're going to be having no reaction with water or steam. And when the nitrate decomposes, it will form a metal, nitrogen dioxide, and oxygen. So for the metal that is most likely to form a soluble hydroxide, we would have to go with YC. And then for 42, which of the following pairs of metals is the first metal, or in which of the following pairs is the first metal most likely to displace the second metal from solution? So we just organized it, right? We said that in order of reactivity, most reactive would be Y, then Z, then X, then W, right? So this is just asking which of these pairs looks like this order, right? Because as we know, if it's not more reactive, it will not displace the metal, right? And so for this one, the one that I see would be B as in boy, right? Number 43. Which of the following statements about a homologous series is correct? We saw this one before, right? So we know our answer. What should our answer be here, guys?
D.
D as in dog. Beautiful, right? They differ successively by a CH2 group. Wonderful. Next question. 44. Here we have a beautiful compound. Can anybody name that compound for me? All right. So this one would be 2,2-dimethyl butanol, right? According to the naming system that you learned, which is the IUPAC naming system, right? Now, let's look carefully at what the question is going to ask us. Which two of the following phrases correctly describes the compound shown? Right? So the first thing is that, is this an alcohol? Can we agree that this is an alcohol?
Yes, miss.
All right. So that means that C and D would be out, right? If it's an alcohol, then it can't be a branched alkane. So 2 would be out automatically, right? Second, 3 says, is it reactive with sodium? Is 3 correct? Are alcohols reactive with sodium? Yes, they are, right? And finally, it says not reactive with acidified, potassium dichromate, right? And we know that that's not true because with our breathalyzer test, right? That's actually how we get our breathalyzer test to work, right? We use acidified potassium dichromate, and in the presence of alcohol, we see a color change, right? And so that's how we know. So we know that it's not 2 and it's not 4, so it has to be 1 and 3. Next question. Which of the following molecules could be obtained by cracking the alkane C8H18? So remember we said that for whenever we crack a long alkane or a long chain alkane, we're gonna get two small chained compounds. We're gonna get an alkane and an alkene, right? And so here we can see before us, one is ethene, which is a small chain alkene, and then 2 is hexane, right, which is a small chain alkane. Here now, we have something very different, right? We have C16H34. And what we know is that this is going to be an alkane. But how can we break down something small to create something big? It's impossible, right? And so it would be 1 and 2 only. Does everybody understand how we get 1 and 2 only? All right. So let's go back over it because we said we don't quite get it yet. All right. So here we are, right? We said we have C8H18. And when we crack it, we're going to get 2 compounds, an alkane and an alkene, right? Now, how do we know that number 1 is an alkene? Because it has the formula CnH2n. How do we know that 2 and 3 are alkanes? Because they have the formula CnH2n plus 2, right? So that would be C6H14 and C16H34, right? Now, if we're starting out with C8, right? Then when we're breaking it down, we can't form C16 because C16 is big. We'd have to build it up to form C16, right? So if we're breaking it down, we can't form C16, H34, so that's why 3 is out. However, we have satisfied the rest of what we need, right? We have satisfied the need for an alkene and for an alkane with 1 and 2, and that's how we get 1 and 2 only. All right? Does everybody understand now, or do you understand better now? All right, awesome. 46. A major source of alkanes and alkenes is
Petroleum.
beautiful answer, petroleum, right? All right, we're going to move on to our next question. Which of the following substances is a product of halogenation with methane? So we know that with our alkanes, halogenation is a substitution reaction, right? So if we have methane, right, which we know is CH4, then that means one of the H is going to have to be substituted when we add our chlorine, for example, right? If we were to add chlorine, what we would come out with is chloromethane, so you'd have Cl, CHHH plus HCl. Do we see HCl here? Yes, we see hydrogen chloride. All right, does everybody understand?
Yes, miss.
Okay, awesome. How many isomers of butane are there? Now this one can trip you up, but in the middle of an exam where you may not have as much time, it's important to use any of the mnemonics or shortcuts that you do remember, but you have to make sure that you really remember them, right? Because you don't want to make a mistake. So for 48, what I do to remember the amount of isomers that can be made by an alkane is that starting at C4, we start making or forming isomers, right? Because C1, methane, C2, ethane, C3, propane, these are incapable of making isomers. But we start making isomers at C4. And isomers would be at least two different ways of writing or depicting this empirical formula. Sorry, this molecular formula, right? So here we have C4H10. And for C4H10, we have two isomers. But I'm going to give you a little table so that you remember how to do this, right? So let's start. So we said we start with C4. Number of carbons to number of isomers. So if we have 4 carbons, we make 2 isomers. 5, 6, 7. If we have 5 isomers, we make, 5 carbons, we make 3. If we have 6, we can make 4. If we have 7, we can make 5, and so on and so forth, right? But yes, so the answer here would be B as in boy. Wonderful, right? Because here, butane is when we can start making isomers. And the isomer that we would be able to form here would be what? It would be 2-methyl propane. That would be the isomer that we're capable of forming for butane, all right? Now, let's continue. We're almost finished with this paper. So 49. Which of the following substances is an unsaturated hydrocarbon?
Vinegar.
Vinegar. All right, so for this one, it wouldn't be vinegar. The active ingredient in vinegar is actually ethanoic acid, right? Which we know is CH3 COOH, right? And so we don't have any double bonds here. So remember, unsaturated just means that it has at least one double bond, all right? So if you don't want to make it as simple as that, to say at least one double bond, you're really thinking of it as not being fully satisfied or saturated with hydrogens. So that means there's a multiple bond somewhere. So whether it be an alkene or an alkyne, right, which has a triple bond, that's what makes it unsaturated, right? It doesn't have all of its bonds supplied by either a single bond with an element like itself, whether it be carbon or oxygen, etc. or a single bond with hydrogen. So here, our answer would not be A. Any other guesses for this one? All right, so I'm seeing B, and yes, our answer would be B as in boy, propene. All right, so items 50 to 52 refer to these substances that you're seeing here. All right, can we name any of these substances, guys? So for this one, A would be propanol. How do we know? First and foremost, this is an alcohol, right? And alcohols go by the formula CnH2n plus 1 OH, right? So that's what we're seeing here with C3H7OH. And we know it's propanol because it's C3. Next would be
Propene.
propene, beautiful. Next would be
Propane.
propane, wonderful. And the last one, what do you think this one would be? I know this one looks a little different, but all you really need to do is count up your carbons, because we know this is going to be an alkanoic acid, right? So how many carbons do we see here? 1, 2, 3, 4, right? Because it's C2 here. So that would be butanoic acid, all right? So now here, from here, we can move forward, right? So 50 says, which of the substances is a saturated hydrocarbon? What do you guys think for that
C.
one? All right, so you said C. All right, beautiful. 51. Which of the substances is a compound that is soluble in water? I know this one may be a little bit more tricky, but the presence of this OH on our alcohol allows it to be soluble in water. So we're gonna go with A for 51, all right? For 52, which of the substances is a compound used as a monomer, in addition polymerization? All right, so we have D as in dog. But remember now, this one is addition polymerization, right? And remember, we said for addition polymerization, we use unsaturated hydrocarbons. So the answer here would be B as in boy instead. All right. The functional group present in carboxylic acids is
B.
all right. B as in boy, beautiful. 54. When a hydrocarbon molecule is cracked, which two smaller molecules are produced?
A.
Beautiful. Number 55. With which of the following substances would an alkane react?
Chlorine.
Beautiful, but how you get chlorine for this one?
Because that's a substitution reaction.
Beautiful. You guys are on a roll. All right, 56. Which of the following molecules represents butene?
Is it B? Although for A, I'm not sure if it's on the first carbon or the second one, because it looks like it's on both of them, so I don't really know. It's either A or B.
All right. So it's actually B as in boy, so you were right. Don't know yourself. But think about it this way. It gets the name of the carbon that it's attached to first. So think about it as, okay, if I'm closer to the end here, it might double bond this here, touching carbon 1 and carbon 2, right? Then it would be but1-ene. But if it's in the very center of butene, where it's touching carbon 2 from this angle, and if we're counting from here, it would also be carbon 2 from this angle, right? Then this would be the perfect scenario for a but2-ene, right? I don't know if you guys learned that yet. Yeah. Do you guys know what kind of isomers can be formed from a compound like but2-ene? No? All right.
No, me.
All right. Thank you, guys. All right. 57. Which of the following features is not true of all homologous series of compounds?
D.
D as in dog. Beautiful. 58. So we're basically at the end of this paper, right? Which of the following substances can be produced directly from ethanol? Guys have any ideas for this one? All right, so I'm seeing C as in cat, and no, it wouldn't be C, and no, it wouldn't be A either. So for this one, it would be B as in boy, right? And let me explain. All right. So for one, ethene, if we dehydrate an alcohol, we get an alkene, right? And that's a one-step process. And so I would be definitely one of the answers, right? So that means that's why it couldn't be C. But then also for 4, ethyl ethanoate. Ethyl ethanoate is what? Is it an, what kind of compound is ethyl ethanoate? You guys know?
Ester.
Right, it's an ester, right? And it's a one-step process to form an ester, is it not? Right, because remember for our esters, all you have to do is react the alcohol with what? What do you react with alcohols with to form esters, guys?
H2O.
No, guys, no man, no man. So remember, to form an ester, you react an alcohol with a carboxylic acid, right? And so that's how we get B as in boy. Because to get to sodium methanoate would take more than one step. To get to ethane would also take more than one step. So that's why we're choosing 1 and 4 for 58. All right, 59. Particles in a gas are A, very closely packed together, B, have strong forces between them, C, get larger when heated, D, can move in any direction. What's the answer for this one, guys? C? Pardon me, did you say C as in cat?
No, Miss, D as in dog.
D as in dog, wonderful, right? They can move in any direction, they're not limited, right? All right, and last question for this paper. Which of the following compounds can decolorize potassium manganate?
A.
A, beautiful, right? And that's because of this lovely double bond, right? Which facilitates what kind of reactions? All right, so that means I have to go over it, right? That double bond facilitates many different kinds of reactions, but most notably, it facilitates addition reactions. That's what it's most known for, addition reactions. All right, guys? So we're at the end of another paper. Would you guys like to take a break or would you guys like to continue? All right. So in the interest of, oh, you like to take a break. All right, cool. All right. I guess here we could take a 10-minute break. How does that sound? A 10-minute break?
Yes, miss.
All right. I'm so hungry. Hi everyone. Are you guys ready to start again? It's time to start again. All right. Can you guys hear me? Yeah? All right, awesome. So I'm gonna start recording again once I have shared my screen. So let me start sharing. Ready? All right, guys. So the plan is to do a few more papers, just 3. Hopefully you guys will stick through to the end. But yeah, let me start recording now. All right, awesome. So now we are on to May, June 2017. All right. Which of the following processes provides evidence for the particulate nature of matter? We saw this one before, and we had agreed that it was diffusion and osmosis, so that would be 1 and 3. Number 2, which of the elements above forms a chloride that is ionic in nature? Right? So what are you guys thinking for this one?
C.
C? Wonderful. I think so as well. Right? Because that sort of high melting point and high boiling point is characteristic of things like metals, things like ionic compounds, things like that, right? So that's why we're choosing C, which is 3. Which of the following elements has 7 electrons in its outer shell? We know that those are our halogens. So which one is that?
Chlorine.
Chlorine, perfect. And we already, mentioned a few others like iodine, bromine, and fluorine. Let's continue. An atom has 20 electrons. When it ionizes, it has the same electronic configuration as, and we saw this question before and we said it was argon. But just to recap, I said it was argon because, as we said, it has 20 electrons, right? In its atomic state, which is when it does not have a charge, right? And so we know that if it is an atom with 20 electrons, that has to be calcium, right? Now, when it ionizes, it loses 2 electrons. So it now has 18 electrons. And 18 electrons corresponds to argon in its atomic state. So that's why we're choosing argon for number 4. Number 5. Which of the following elements does not form simple ions by gaining or losing electrons?
A.
A, carbon, right? And we know that carbon is very special because it has 4 electrons in its outer shell. So it doesn't really form simple ions. Instead, it engages in the formation of more complex ions. So like your carbonate, your hydrogen carbonate, but then also it engages in a lot of other sorts of bonding. So for example, when we're talking about our organic compounds, we start thinking of words like catenation, right? Which is the ability of carbon to form, these rings and chains and all these various structures by binding to itself, right? So now let's continue. Question 6. Let's zoom out. Some calcium carbonate was reacted with excess dilute hydrochloric acid. The volume of carbon dioxide evolved was recorded and plotted against time. Which of the following graphs represents the reaction? So when we're looking at, reactions, especially those that produce gaseous products, right? We know that over time, more and more will be produced until we plateau, right? But especially with the formation of gaseous products, what we'll notice is that, it starts off with a tiny phase and then it starts to effervesce rapidly until, things start to cool down a bit. And so which graph do you think properly, shows this? Would you say it's graph A, B, C, or D? All right. So we have a volunteer who said it's A, and I agree. It is A, right? So here we see, a small amount being produced at first, but then over time it gets, more and more until it starts to plateau, as with most reactions, right? Now, which of the following represents a balanced equation for the reaction between aqueous silver nitrate and aqueous sodium chloride? Any ideas for this one, guys?
A.
A, wonderful. Number 8, which of the following acids will not form an acid salt? Which one do you think it is, guys? Which of the following acids will not form an acid salt? All right. So for this one, okay, I think we have a volunteered answer here. D as in dog, yes, I do agree as well with ethanoic acid, right? Because it's a weak acid, and so that's really the major difference here, right? It's a weak acid, but then also it's monobasic. So it's like not the typical, not what's going to actually form an acid salt, right? All right, number 9, sodium reacts with water according to the equation. So you have 2 sodiums reacting with 2 molecules of water to form sodium hydroxide and hydrogen. Now we saw this question before, right? Right, so yes, we would know that the answer here is A, 1.2, right? And so just the long and short of it is that if we have 2 molecules of sodium to 1 molecule of hydrogen, and the number of moles of sodium is 0.1, and the number of moles of hydrogen has to be half the number of moles of sodium. So it would be half of 0.1 to give 0.05. And with 0.05 moles, if we were to multiply this 0.05 moles by the volume per liter, which is 24 liters per mole, then we would get 1.2 liters of hydrogen at room temperature and pressure. All right. Which of the following oxides may show acidic and basic properties? We all saw this one before as well.
B.
B as in dog. Beautiful, right? All right, number 11. A mixture of copper 2 oxide and copper 2 sulfate is best separated by any ideas? All right, so I'm not seeing anybody with any ideas right now. In the interest of time, I'm gonna just explain it to you, right? So it is a mixture of copper 2 oxide and copper 2 sulfate. The major difference between these two is the solubility, right? So we know that our copper 2 oxide is not soluble, right? But our copper 2 sulfate, is very soluble, highly soluble. So in order to separate them, all we need to do is shake them in excess water and then filter. What would be removed with our water would be our aqueous copper 2 sulfate, where copper 2 oxide would remain a solid, and so that would be filtered out. All right. Which of the following elements exhibits allotropy? Right, and so this is just different forms of the same element, but they're arranged in different arrangements, right?
Carbon.
All right, beautiful. Do we know any other ones that exhibit allotropy?
No.
All right, so outside of carbon, phosphorus also exhibits allotropy and sulfur as well. Next, which of the following statements is true of an endothermic reaction? Endothermic.
Heat is absorbed from the surroundings.
Heat is absorbed. Beautiful, right? Next, in which of the following substances will electrolysis not occur when an electrical current is passed through it? We saw this one earlier as well.
Solid C.
All right, beautiful. Solid sodium chloride. Number 15. Which of the following are physical properties of ionic substances?
D.
Any ideas? Oh, you said A as in apple?
D as in dog.
D as in dog. All right, so let's look carefully at it, right? So we know that they have high melting points. That's correct. We also know that they are good conductors of electricity in the liquid state. Fine, beautiful, right? But it says here soluble in organic solvents. Now, organic solvents do not dissolve or ionic substances very well, right? They're pretty insoluble in organic solvents, right? And that's because of this rule called like dissolves like. So what you'll notice is that an ionic substance is an inorganic substance, right? Typically, it's inorganic. So instead of being soluble in organic solvents, it would be more soluble in inorganic solvents like water. And so the answer for this question would be 1 and 3 only, B as in boy. Number 16, which of the following substances, when added to pure water, significantly increases the water's conductivity?
Sodium chloride.
Sodium chloride, which is an ionic compound. When we have our ionic compounds, what happens is that they dissociate to form ions, and these ions are charged. And so that's how we have electrical conductivity being able to take place, right? Or electrical conduction taking place, right? Because conductivity is a quality. All right. 17, a separating funnel can be used to separate a mixture of which two? Remember, we saw this one as well.
B.
B as in boy. Beautiful. Right? Number 18, which of the following terms describes sodium chloride? So it's ionic crystal, simple molecular, macromolecular, or metallic. Sodium chloride, guys.
Ionic crystals.
Ionic crystals, beautiful. 19, which of the terms describes the structure of copper?
D.
D, metallic, wonderful. All right, the pH of fresh sugarcane juice, which is usually 5 to 5.5, can be changed to 7.5 to 8 before efficient processing by adding which of these compounds?
Slaked lime.
Ah, beautiful, guys. And that is because we're trying to become more basic, right? So you need to add a base. All right. Which of the following statements describes acid salts? We saw this one as well.
C.
C as in cat. Wonderful. 2 and 3, which says that they form a normal salt when all the replaceable hydrogen is removed. And also their anions dissociate to give hydrogen ions. All right, wonderful. We are on a roll. 22, a piece of metal is reacting with an acid to produce hydrogen gas. Which of the following procedures should be employed in order to increase the rate of the reaction? Any ideas for this one, guys?
A.
A as in apple. Beautiful, right? Because if we increase the temperature, then we increase the number of collisions, right? Taking place, because all of the particles have more energy. But then also if we subdivide the lump of metal, then we increase the surface area over which collisions can take place, right? And so we know that there's two things that cause our reactions to take place. There has to be a collision of the 2 or 3 or 4 things that are reacting, but then also those collisions have to be effective, right? And so if we increase the temperature, then we increase the number of collisions, which increases the probability of having effective collisions. But then also if we subdivide the lump of metal, we will increase the number of collisions that are actually taking place. All right, 23. The atomic number of an element is defined as the number of what? Electrons, protons, protons and neutrons, or electrons and neutrons?
Protons.
All right, beautiful. Right, so here they ask for the atomic number, right? Now, which of the following halogens is a liquid at room temperature?
A.
A, bromine. Which of the following statements is true for the equation below? All right. So for this one, what we can do to make this a lot easier for ourselves is to start the calculations from early, right? We see that they're only going to be asking us about hydrogen and magnesium. So let's not worry too much about the sulfur or the oxygens, right? We're just going to look at those as ions on a whole. Magnesium as a solid, 0. Hydrogen in H2SO4, which is sulfuric acid, would be +1. Magnesium in magnesium sulfate, +2. Hydrogen as a gas, 0. So when we're looking at it, if we're moving from 0 to +2 for magnesium, that is oxidation, right? And we see that here, C, magnesium is oxidized from 0 to +2, right? Why? Because oxidation is a loss of electrons, right? And so as you lose electrons, your oxidation state or oxidative state goes up. Everybody understood that one, or you want me to go over it? Everybody understood? You guys still with me?
Yes,
Yes,
ma'am.
miss.
All right, awesome. Let's continue. The element that is used to determine the relative atomic mass of another element is
B.
B as in boy, carbon 12, the poster boy. All right, next. Here we have the various tests for gases, right? Now, which test can be used to identify an acidic gas?
A.
A.
A, all right, great. Which test can be used to identify ammonia gas?
B.
B as in boy, brilliant. All right, 29. Which of the following does not take place during electrolysis?
B.
All right, beautiful, because we know that anions move towards the anode, right? Next question. Which of the following illustrates the course of an exothermic reaction? Here we are, this is what we're looking at, guys. Exothermic reaction, what's the answer?
A.
A, wonderful. An atom with an atomic structure as shown, right? So 13 is the atomic number and 27 is the mass number, contains how many protons and neutrons?
C.
B.
So I'm hearing C and I'm hearing B. Which one is it, C or B?
C.
B.
C as in cat, wonderful, right? Because we said our mass number is 27. 27 minus the number of protons, which is 13, is going to give us 14 neutrons, right? So it's 13 protons, 14 neutrons. All right, we also saw this one, but let's look carefully, right? Which of the following molecular formulae represents the alcohol, whose boiling point is 180 degrees Celsius? So if we are to look carefully at this, we would see that each increment is 10, right? So 150, 160, 170, 180. Let's take that across to the line. Make sure that it's on a straight line. right? And it would end at 7. Not sure what's happening there. Well, yes, it would end at 7 for 180, right? It would end at 7. So if it ends at 7, when we extrapolate, that means it has to have 7 carbons in the chain. Now, which one of these has 7 carbons in the chain? That would be D as in dog. So we have 1 here. 6 times C. It was 6. 6 plus 1 equals 7. 33. To which homologous series does the following structure belong?
A.
A, carboxylic acids, right? 34. Which of the following is the name of the compound CH3, CH2, CH2, CH2OH? So if it were me looking at this, I would just go, okay, they're not asking for too much specifics. I'm not seeing any branching or anything. So the next thing to do would be to count the number of carbons. So 1, 2, 3, 4. 4 carbons. So what does that sound like, guys? Propanol or butanol?
Butanol.
Butanol, right. Now, the OH goes on the most important carbon, carbon 1, right? So this would be 1 butanol. Not 4 butanol, 1 butanol, okay? Now let's continue. Which of the conversions above correctly represents the dehydration of ethanol? So in order for us to know what that would be, we have to know what kind of product we're looking for, right? So in the dehydration of ethanol, we produce an alkene. So which of these shows that? A, B, C, or D, guys? Any ideas, guys? All right. Not seeing any feedback there. But as I said, when you dehydrate ethanol, you're going to get ethene, right? And that's being depicted by C. How do we know that? Alkenes have the formula CnH2n. So if there's 2 carbons, there's going to be 4 hydrogens, right? Just double the amount of carbons to get the hydrogen number. Number 36, A, would be the answer for that one. How do I know that it requires potassium permanganate? Because this is exactly what our breathalyzer test is doing, right? But essentially, potassium permanganate, actually no, not the breathalyzer test, sorry. This is why you would need a strong oxidizing agent like potassium permanganate is what I really meant to say, right? Potassium permanganate is able to oxidize ethanol to form a carboxylic acid. So that's why we're going to go with A. Does everybody understand?
Yes, miss.
Okay, awesome. Remember to tell me to slow down if I'm going too fast. All right. Organic acids, alcohols, plus alcohols make esters and water. The forward reaction is known as what, guys?
Esterification.
And the reverse?
Hydrolysis.
Hydrolysis. Beautiful. Whenever we have cracking taking place, right? What is formed?
A.
A, right? So we get a large alkane molecule being turned into a smaller alkene and alkane. Good. Let's keep it going. 40. RCOOH, that is carboxylic acid plus sodium hydroxide, give us sodium ethanoate or sodium alkanoate because we have R instead of an actual R group. And then we also have water. Which of the following processes correctly describes the equation above? What kind of equation is this? It's an acid and base forming a salt and water. What kind of equation is that?
Neutralization.
Neutralization reaction. Beautiful. All right. Then we have 41. An organic substance, when reacted with bromine water, decolorizes it immediately. The substance is most likely no ideas for 41, guys? Alrighty. So remember we said that our alkenes have that double bond, right? Because they are unsaturated. And so they facilitate addition reactions very easily. So in the presence of bromine water, if you want something to, decolorize it, you're going to have to use something that is either a very strong reducing agent or something that is unsaturated, like an alkene. Next question. Glucose is converted to starch or cellulose by, and we saw this question before. Any ideas for 42, guys?
C.
C as in cat. All right, so for this one, it would actually be condensation polymerization. So you guys probably need to just do a little bit of review on it. Because remember the condensation polymerization, as we said, with glucose, remember we said that when it's added to another glucose, water is removed. And so that's what makes it condensation polymerization, all right? Compounds in a homologous series do what?
C.
C, they differ successively by a CH2 group. All right. Ethene reacts with hydrogen, chlorine, and hydrogen chloride. These reactions are all examples of
Addition.
all right. Yes, these are addition reactions. Perfect. Number 45. Which of the following substances is not a polymer?
Nylon.
No, not nylon. Want to hazard another guess?
Protein.
No, man, not protein. It would be fructose, right? Because fructose is just a disaccharide. No, a disaccharide only has 2 copies of something, right? 2 copies of a sugar. Nylon, protein, and cellulose are all polymers. Okay? 46. Which of the following methods is used for extraction of aluminum?
A.
Okay, wonderful. A, electrolysis of its molten oxide. 47, which of the following statements about sulfur are true?
B.
B as in boy, 1 and 3 only. Wonderful. All right, 49, 48, and 49. Soapless detergents are
D.
D as in dog, right? They're not affected by hard water. That's the incentive of using them because they won't make any scum. All right, 49. A solution when treated with sulfur dioxide gas becomes green. The solution contains
Dichromate 6.
beautiful dichromate 6. All right, number 50, a suitable drying agent for the laboratory preparation of ammonia gas is, remember we went through this, so this was in the first paper, guys.
A.
Wonderful, it is A. 51, when copper 2 carbonate is heated alone in a dry test tube, a gas is evolved and a black residue is formed. The gas is expected to do what?
D.
All right, wonderful. Because we know that gas is going to be CO2. An element that is a non-metal is what? Any ideas for this one, guys? Number 52.
C.
C as in cat forms an acidic oxide. Yes, that is true. Because remember, metals are the primary reducing agents. It's a solid at room temperature that more applies to metals and non-metals and conducts electricity. Also applies to metals, not so much non-metals. 53, which of the following observations is likely when excess ammonia is added to a solution of copper 2 sulfate and the mixture is shaken? So this one is a qualitative analysis question.
D. No, wait. C.
Right, so that would be right, so that would be C as in cat, right? A D blue solution. All right, next question. So keep in mind these metals at the top here. Now, which metal reacts vigorously with water to produce a strongly alkaline solution?
D.
D.
All right, lovely, lovely. Everybody's learning. 55. Which metal has an alloy which is used in the manufacture of aircrafts?
A.
A as in apple, right? And as our friend said, it is duralumin that is the alloy. All right. 56. Which reaction is least likely to occur?
I think it's B.
D as in dog or B as in boy?
B as in boy.
B as in boy. Okay. Why?
Because copper cannot displace silver because it's lower than silver. No, wait. Actually, I'm not sure, but it has to be one of them that's lower than the other one in the reactivity series.
All right. So you have the right concept in your mind. It's just to make sure that you have the right answer on the day, right? So the answer here would be D as in dog, and that's because sorry, lead is below iron. So lead is incapable of displacing iron, okay? The main substances responsible for acid rain are
D.
D as in dog. Beautiful, everybody's learning. 58. Which of the following observations is expected when aqueous silver nitrate is added to potassium chloride?
C.
C as in cat. Does everybody agree? Because I do. Which metal appears between copper and aluminum in the reactivity series and is an important component in hemoglobin?
B.
B as in boy. Beautiful. 60. Which of the following gases will give a positive test with dry cobalt chloride paper?
D.
D as in dog. And what's the color change? Remember, it's blue to pink, all right? Alrighty. So we've just completed another paper in under an hour, right? So with the rest of the time, you'd be able to get a chance to, look over your paper and see if there's anything that you would want. So alter anything you'd want to change in order to score maximum points. All right, you guys are ready for the next paper?
Yes, miss.
All right, awesome. Can you guys see my screen?
No, miss.
All right, thank you. So let me continue here. Screen. All right, awesome. All right, can you see now?
Yes, miss.
All right, ready for our new paper. So as you could see, there's a lot of repeats that come, but it's important to focus on the repeat that you may think you get, because sometimes it's not the same exact question. And so you might put the same answer as before and get it wrong. So let's keep looking. Which of the following processes suggest that matter is made up of minute particles?
A.
A. Mass number is the number of?
A.
A.
All right. When an exothermic reaction occurs, energy is?
Released to the environment.
Released to the environment. Beautiful. 4. Which of the following statements best describes the difference between an atom and an ion?
D.
All right, beautiful. So it says that an atom contains equal numbers of protons and electrons, And an ion contains unequal numbers of protons and electrons. Beautiful. All right, number 5. Which of the following pairs of elements are isotopes?
C.
C as in cut is correct. So we say it's Q and S, right? So the number of neutrons are different, but the number of protons are the same, and the number of electrons are the same. We have isotopes. 67. Which of the following elements is an anion? Looking back, an anion, negative ion. Any ideas, guys? Let's see if there's anything in the chat. Nothing. All right. So remember, an anion has more electrons than protons. So here we have T as our anion. The element Q, going back up, the element Q is what? 8 protons. That would be oxygen. All right, awesome. Thank you. Barium is below calcium in group 2 of the periodic table. When both metals react with water, the main observed differences would be the rate of reaction and the
D.
D as in dog. Wonderful. Solubility of the product. And we said calcium hydroxide is much more soluble than barium hydroxide. Which of the following aqueous solutions contains 1 mole of hydrogen ions?
A.
A as in apple, and we said it can't be D, even though it looks like it would be the same amount. It can't be D because ethanoic acid is a weak acid, which means it does not completely dissociate in solution, which means 1 mole of the acid will not produce 1 mole of the ions. Which of the following substances does not conduct electricity? In the interest of time, guys, I'm going to tell you that it's ethanoic acid. And that's because, as we said, it does not dissociate fully. So it's unable to really facilitate the conduction of electricity as much as the others that we have here. A new element R shows chemical properties similar to the element sodium. What is the correct formula of a compound formed with R and sulfur? Anybody know this one? We had it in our first one. C, right? Because remember, R is going to be the same as sodium. Sodium has 1 valence electron, so R may just have 1 valence electron also because they have similar chemical properties. And so in reacting with sulfur, which is, you know, has the capacity to gain 2 electrons, then we will use R2S as our formula. Which 2 elements above, when combined with each other, form an ionic compound?
A.
A, 1 and 2.
No, B.
B, 1 and 3, right? And remember, we went through this one. We said that A would be 2, 1. That would be a metal. This would be 2, 4. That would be, yes, a non-metal, but not the type of non-metal that forms simple ions, right? 2, 8, 7 is a halogen. Metals and halogens form perfect ionic compounds, essentially. And then 288 would be a noble gas, no compounds really being formed. All right, the number of shared ionic pairs in methane is
A.
A, right? 4. Now, for those of us who probably never really, were able to see it properly, I'm gonna just draw my little dot and cross diagram. So we have C, right? Forget the inner shell. We're just gonna talk about the valence shell now, right? So in my valence shell, I have 4 electrons, right? So that we add 4 hydrogens. How many pairs is this? 1, 2, 3, and 4. So it's A, 4. Which of the following statements best describes the formation of a metallic bond?
D.
G, right? The cations are held together by a sea of mobile electrons. 15. A solution having a pH of 1 will do what?
B.
Right? Because we said acids, pH of 1, react with metals to form hydrogen and a salt. 16. The electrolysis of aqueous copper 2 sulfate solution using copper electrodes. In that electrolysis process, what happens to the anode?
A.
Right, it decreases in mass. And this is what happens in refining, right? Electrorefining of copper. All right. Here we have our options, period 2, group 2, group 7, and period 3. Which set of elements forms molecules which contain 2 atoms?
Group 7.
All right, we're correct. Group 7, which are our halogens. 18, which set of elements has atoms with 2 electrons in their outer shell?
Group 2.
Group 2, and that is B as in boy. All right, we're almost there, guys. Which of the following statements is true of carbon monoxide? Any ideas for this one, guys? All right, what I'll tell you then is that carbon monoxide is a neutral gas. It's not very soluble in water, and this is not carbon dioxide, so it does not turn lime water milky. Instead, it's a very good reducing agent, and it reduces iron 2 oxide. 20. Adding dilute sulfuric acid to which of the following copper compounds would be the least suitable method for preparing copper 2 sulfate? B. Right, it is B, copper 2 chloride. 21. Which of the following statements is not true?
C.
C as in cat. Copper is a strong electrolyte. Right, that is true. Well, not true, rather. Yeah. All right, 22. Which of the following techniques may be used to separate a mixture of plant pigments into their individual components?
D.
All right, beautiful, paper chromatography. All right. Next question. Items 23 and 24 refer to that equation at the top there. Right, so which of the following compounds is being reduced in this equation? So remember we said that oxidation is a gain in oxygen sometimes, and and reduction is a loss in oxygen sometimes. So what's being reduced here would be the nitrogen dioxide, because when we get to the reactant side, it only has one oxygen instead of two. All right. So in that way, it's being reduced. But even if we were to look at it from another angle, right? NO2. NO2 here would be, the nitrogen would have a +4 charge, but now it has a +2 charge, and that's a reduction in oxidation state, which is also a reduction overall. All right, 24. Which of the following compounds is the oxidizing agent? It would also be NO2. And why is that so? Because the one who is being reduced is the oxidizing agent, and the one who is reducing, the other one, right, is the one that is being oxidized. So if you are being oxidized, you are the reducing agent, and if you are being reduced, you are the oxidizing agent. 25. Which of the following substances, when added to pure water, significantly increases the water's conductivity? We saw this one more like very often. D as in dog. Beautiful. 26. Which of the following diagrams best illustrates the course of an exothermic reaction?
A.
A, wonderful. We're almost halfway through this paper. A substance Y reacts with an ammonium salt to produce ammonia gas. Y must therefore be what? Any ideas for this one, guys? All right, so what I want you to do is think about it this way, right? Ammonia, NH4. It has the ability to act as an acid, right? Because it can donate one of these hydrogens. Sorry, ammonium salts, let's say NH4, just put something random, right? It can donate one of the hydrogens from this cation, right, to another substance and that would produce NH3 plus the new salt plus, water, depending on what was there, but typically it would be ammonium, salt, and water. Sorry, ammonia, salt, and water, right? So here, substance Y would be a base, because when it reacts with ammonium and ammonium salt, the ammonium salt acts as an acid, releasing ammonia gas, a salt, and water. 28. An example of a substance with a giant covalent structure is B, diamond. Wonderful. An ion with a single negative charge may be converted into a neutral atom of the same element by doing what?
D.
Guys, remember that for this one, for example, if we have O2 minus, if we have, let's do that, O2 minus, right? What do we have to do to change this to O?
It gained 2 electrons.
No, in that case, we'd have to lose 2 electrons, right? Because if we're moving from a negative charge closer to 0, we have to lose those negative charges, don't we? And since we can't gain positive charges, we have to throw off those negatives, and the only thing that's negative would be an electron. So let me see if I can properly explain it for you. So if we're moving from, let's say we're looking at a number line, right? -2, -1, 0, 1, 2, right? We're starting here, right? Now, in order to get to 0, we have to move closer and closer to 0. So we have to lose 2 of our negatives to get to 0, right? And so it works with any anion, right? If you want to, become stable, so to speak, you have to lose electrons. Question 30. On adding aqueous hydrochloric acid to a solution in a test tube, a gas is given off which extinguishes a burning splint. This shows the presence of what?
D.
D as in dog. All right. D as in dog, it is 31. The main substances responsible for acid rain are
C.
C as in cat. Wonderful. Z may best be described as, so Z is a brown gaseous oxide, which is soluble in water. It turns moist blue litmus paper red.
C.
Right, an acidic oxide. Sulfur is used in which of the following processes?
B.
B as in boy, 1 and 3 only. Remember, it's not involved in the extraction of iron from its ore. 34, which of the following metals will not displace hydrogen from dilute hydrochloric acid?
C.
C as in copper. All right. 35, which of the following lists contains all of the raw materials used in the extraction of iron? Remember we saw this before, guys. So just a reminder, no cryolite is involved, no bauxite would be involved. This list is incomplete. It would be air, coke, iron ore, and limestone. Number 36. A property of metals is that they tend to do what?
A.
Beautiful. They tend to lose electrons, and in losing electrons, they become positively charged, right? Now, which of the following procedures can be used to identify ammonia gas?
B.
B as in dog, you are correct. And what we're expecting to see is that the red litmus paper will become blue. All right. Why is aluminum more resistant to corrosion than iron?
C.
C as in cut, right? Aluminum oxide protects the aluminum, but the iron oxide does not protect the iron. Which of the following diagrams best illustrates bonding in hydrogen bromide?
D.
D as in dog. All right, so with hydrogen bromide, we have hydrogen and a halogen, right? So we know there's going to only be one shared electron pair. So that's D as in dog. How many covalent bonds are there in a nitrogen molecule? Any ideas, guys, for this one? So we have to remember that nitrogen is in group 5, right? And so in order to be satisfied, it just needs 3 more electrons. So when we look at the nitrogen molecule, what we'll notice is that there are 3 covalent bonds to help satisfy it and make it more stable. All right. Which of the following metals is likely to form a soluble hydroxide? We had seen this one earlier in our questions.
C.
C as in cat, which is why, and we know that because it reacts rapidly with cold water, and the nitrate breaks down to form a nitrite and oxygen, which means it can only be one of 2 options we know, which is potassium and sodium, and both of them have soluble hydroxides. Number 42, aluminum is manufactured by the electrolysis of pure molten aluminum oxide, while iron is manufactured by the reduction of its ore, hematite. Iron 3 oxide. Now, which of the following statements about aluminum and iron is correct?
C.
C as in cat. All right. Why would you say C as in cat? Any ideas as to why you're saying C as in cat?
Miss, because of the statements given in 42.
Okay. Well, truthfully, the answer would actually be B as in boy, but aluminum is more reactive than iron. It wouldn't necessarily be that iron cannot be obtained by electrolysis, but it would be a more labor-intensive process, essentially. So when you think about it, aluminum, being that it lies higher up on the reactivity series, is way more reactive than iron. And so that's basically it. Essentially, the earlier statement here is more fluff, right? They just really want to know if you're aware of the differences between iron and aluminum in terms of their reactivity. All right, now we're going to be moving on to 43. Which of the following substances is an important constituent of chlorophyll?
D.
D as in dog is correct. Magnesium. Which of the following metals will not react with water under any condition? Any ideas, guys?
Is it copper?
Yes, it is copper. Wonderful. All right, next question. Which of the following metals forms an oxide which cannot be reduced by hydrogen? Essentially, this one is just asking which one stands out, which one is least reactive.
C.
C as in cat. Wonderful. All right, we're almost through with this paper, guys. Now we're on to 46 and 47. Which of the following compounds contains saturated hydrocarbons? Or it contains a saturated hydrocarbon of these? Any ideas, guys? All right. So for this one, it would be A, natural gas. What is natural gas? Methane, right? Which is CH4, which would be an alkane. How about 47? Which of these compounds can be dehydrated? Is it natural gas, propene, ethanol, or vinegar?
C.
C, wonderful, ethanol. And when you dehydrate ethanol, we get ethene. All right, let's move on to item 48. How many isomers of butane are there? So remember what we said, right? How many isomers are there of butane? C4H10.
2.
2, beautiful, 2 isomers. Ethene cannot be directly converted to all right, so I noticed that you guys have a little bit of difficulty with these sorts of questions. So I'm going to help you out with 49, right? So ethene can be directly converted to ethane by hydrogenation, right? Ethene can be converted to ethanol directly by hydration. Ethene can be converted directly to carbon dioxide by combustion, right? But to form ethanoic acid, it's a more than one step process. So that's why we said it cannot be directly converted to ethanoic acid. So if we see that again as we move forward, we'll know what to do. All right. Number 50. Which of the following represents a molecule of but2e?
B.
As in boy is correct. All right, here we are. 51. Which of the substances is soluble in water?
A.
Beautiful, right? A, the alcohol. Which of the following substances is used as a monomer in addition polymerization? Anybody have any ideas for B? Sorry, for 52.
B.
Right. So B is, sorry, 52 is B. All right. The major natural source of alkanes and alkenes is?
Petroleum.
Petroleum. Beautiful. 54. When a hydrocarbon molecule is cracked, which two smaller molecules are produced?
A.
A, right? So we said it's an alkane and an alkene are produced. 55. The forward reaction here, where we have an organic acid and an alcohol being used to form an ester and water, is known as?
Esterification.
Beautiful. And the reverse?
Hydrolysis.
Hydrolysis. Which of the following features is not true of all homologous series of compounds?
D.
What did you say? D as in dog?
Yeah.
All right, wonderful. 58. Fermentation of sugars using glucose as substrate can be represented by which of the equations below?
C.
C. Wonderful. So we know that it's this because C6H12O6 is glucose. There is no oxygen anywhere here, as well as we get out our ethanol and carbon dioxide. All right. To which homologous series does the following structure belong?
D.
D, or carboxylic acids. Perfect. Finally, number 60. Which of the following molecular formulae represents the alcohol whose boiling point is 160? So remember, this whole time we had been seeing 180, but now we're seeing 160, right? So now let's extrapolate. 1, 2, 3. So we come down to where we need to have 6 carbons total, right? We need to have 6 carbons total. Then instead of being D, this time our answer will be C, where we have 1 carbon in this methyl group, but then we have 5 carbons here. 1 plus 5 equals 6. All right. All right, guys. So we have 2 more papers to go, and then that will be the end of our session. So we're gonna move right into it. Which of the following processes demonstrates that matter is made up of minute particles?
A.
A. All right. So you see like how we've done so many? We're gonna just, go through these last 2 rapid fire, but if there's anything new that we find, then we're gonna slow down and tackle them, right, purposefully, so that you guys, are properly prepared for your exams. But as you can see, it's a lot of repeats. Now, number 2, in the notation, chlorine, atomic number 17, mass number 35, the subscript 17 represents what?
A.
A, the atomic number, right. From the table below, which of the following substances represented by the options A, B, C, and D is most likely sodium chloride?
C.
C as in cat, wonderful. And we know it's C as in cat because it does not conduct in the solid state. It has a high boiling point and it conducts in the aqueous state, right? So now that's C as in cat. Let's keep going. 4, a salt whose solubility changes to the greatest extent, the salt whose solubility changes to the greatest extent in the temperature range of 0 degrees to 60 degrees Celsius is?
B.
B as in boy, potassium nitrate, beautiful, right? So we see it here. In the temperature range 0 to 60, we have a temperature change of, let's call this, what can we call this? 12 to about 80. That's a difference of 68 versus the rest, right? Sodium chloride does not change. Hydrated copper sulfate does not change half as much as that. Neither does potassium sulfate, right? Next, number 5, which of the following substances supplies protons as the only positive ions in aqueous solutions?
C.
C as in cat, right? Because remember the word protons also means hydrogen ions, H plus ions. All right. Number 6, crystals of sodium chloride are best described as?
Ionic.
Ionic, wonderful. Number 7, the ionic equation for the reaction between an acid and a carbonate is represented by which of the following?
C.
C as in cat, perfect, right? Number 8, when 100 centimeters cubed of 2 moles per deciliter of hydrochloric acid in excess are added to 5 grams of granulated zinc, hydrogen gas is evolved at a certain rate. If 5 grams of powdered zinc is used instead, the rate of production of gas would do what? Increase or decrease, and based on what?
B.
B as in boy, right? It would increase because there's an increased surface area of powdered zinc. And element X has an electronic configuration of 281. At which of the following positions is the element in the periodic table?
C.
C as in cat is correct, right? It would be in group period 3 because it has 3 energy levels, and in group 1 because the valence electron number is 1. All right, here we are, 10 and 11. Which of the properties above refer to a neutron?
B.
Pardon me?
B as in boy.
B as in boy is correct. Wonderful. What about 11? Which of the properties above refer to a proton?
A.
A as in apple. A charge of 1, positive 1, and a mass of 1. Wonderful. 2 solutions are to be mixed in order to demonstrate an endothermic change. Which of the following techniques would be most appropriate?
B.
B as in boy, taking temperature readings is correct. Sulfur, wait, if it's endothermic, what sort of temperature change would you expect to see? Would you want to see an increase in temperature or a decrease in temperature?
A decrease.
Decrease.
A decrease in temperature, wonderful. 13, sulfur and oxygen are in the same group of the periodic table because of what?
C.
They have the same number of electrons in the outer shell, wonderful. How many moles of ethanoic acid are required to produce 0.5 moles of this ester here? So this one is asking about the ratio, right? So if you notice, the ratio is 1 to 1 to 1 to 1, right? So when they ask how many moles of ethanoic acid are required to produce 0.5 moles of the ester, that would be 0.5. Understood?
Yes, miss.
Yes, miss.
All right. Which of the following compounds is covalent?
Hydrogen chloride.
Beautiful. All right. Take note of these acids, right? Which of the acids above has a basicity of 2? What is basicity? Basicity is how much of the hydrogens you can give away, right? That's the easiest way to put it. So which of the following acids, or the acids that are above, have 2 hydrogens to give away?
D.
B as in dog, sulfuric acid. Wonderful. All right, which of the acids above is weakly ionized in aqueous solutions?
A.
A.
Ethanoic acid. Wonderful. Which of the following reacts with an acid liberating a gas which turns lime water milky?
C.
C, calcium carbonate. And which is the gas that turns lime water milky?
Carbon dioxide.
Carbon dioxide. Number 19, which of the following gases shows no reaction with moist litmus paper?
Hydrogen.
Hydrogen, wonderful, because remember this one is basic and these two are more acidic in nature. Now, which of the following properties increases across period 3 of the periodic table?
A.
Beautiful atomic number. All right. A solution of iron 2 sulfate was added until in excess to a solution of barium nitrate. Right, so it's iron 2 sulfate and barium nitrate. The precipitate produced was filtered off, and water was added to the residue in the filter paper. The color of the precipitate produced was any ideas for this one, guys? The color of the precipitate produced?
C.
C, green. All right, why do you think it was green?
Because of the reaction with iron 2 sulfate.
Right, but remember now, the precipitate, right, is what's left back, the thing that is not soluble, right? So if we react FeSO4 plus BaNO3 we're gonna get FeNO3 plus BaSO4. Iron nitrate is going to be a solution, right? So that's not a precipitate. The precipitate is barium sulfate, which is white in color. All right. So try to keep that in mind. What mass of oxygen atoms contains the same number of moles as 112 grams of sulfur atoms? All right. So if there's no answers for this one, then I'll just walk you guys through it, right? So for sulfur, we know we have a mass number of 32, right? The number of moles is equal to the mass that's given over the RAM or RMM, depending on what you have, right? So it'd be 112 over 32. Can somebody give me? Right, so it'd be 112 over 32, right? And that would give us an answer of 3.5. Right? So with this 3.5 now, they're asking us, so that's 3.5 moles, right? Now they're asking us now, okay, what is the mass of oxygen atoms in 3.5 moles of oxygen atoms, right? So the way to figure this out would be to multiply the 16 by the 3.5, and you get 56 grams of oxygen. Okay. The bond between two carbon atoms is this a single bond or a double bond right here? Guys, you still with me? Is this a single bond or a double bond? All right, guys, so look carefully. This one is a double bond, right? And how do we know it's a double bond? First and foremost, what's the valency of carbon? Carbon's valency is 4, right? And so typically we would just say 4, right? 1, 2, 3, 4. But some of the bonds are occupied right now, right? So we have 2 bonds occupied by hydrogen, on both of them leaving 2 bonds left, right? And so what you're seeing here in the shared portion is that you'll have 2 pairs of electrons, right? So 1, 2, 1, 2. And 2 pairs of electrons, each pair of electrons is a bond. So if you have 2 pairs of electrons, then you have a double bond. All right. Which of the following halogens is a liquid at room temperature?
Bromine.
Bromine, right? We saw that one before. A catalyst increases the rate of reaction by doing what?
C.
C. All right, that's the thing now. It does provide an alternative route, right? So you are right there. But then this whole idea of higher activation energy, if it has a higher activation energy, it would be harder for the job to be done, right? So it actually provides a route of lower activation energy so that it's a more accessible or an easier reaction to take place, all right? Number 26, which of the following reactions occurs between propene and bromine?
Addition.
All right, addition. All right, so we have ferrous and ferric, iron chloride, are 2 chlorides of iron. Which of the following statements about these 2 chlorides of iron are true? So essentially here, what you're looking at is the fact that in this one, right, in iron 2 chloride, iron has a 2+ charge on it, right? And it's accompanied by 2 chlorines, right? But then here, iron has a 3+ charge. And it's accompanied by 3 chlorines. So there's just no way that the percentage of iron by mass is going to be the same for both of them. So one has to be in our answer, which means C is out. The colors of the aqueous solutions are different, factual, right? We know that from what we've seen. But then the aqueous solutions of the 2 chlorides do not conduct electricity. 3 is definitely out of it because we know that they both conduct electricity. So it would be 1 and 2 only. All right. We saw this one before. A solid lead nitrate is heated. It decomposes, giving off nitrogen, 4 oxide, and oxygen. The balanced equation for this reaction is all right. So lead nitrate, this is the formula for lead nitrate, right? The answer here is C, by the way, right? But in order to create a balanced equation, we know that, okay, we're going to form the oxide, nitrogen dioxide, right? Which is nitrogen 4 oxide, because that means that the nitrogen has a valency of 4 or has space for 4 bonds to be formed. And we also have oxygen. So if we check this out, this one is the balanced equation that we're looking for. When a metal atom becomes an ion, right? What happens to it? Does it gain electrons or lose electrons? And is it oxidized or reduced?
D.
D, right? It loses electrons and is oxidized. All right, next question. A solution of sodium hydroxide is neutralized by the addition of dilute hydrochloric acid. The results obtained are used to plot the graph below. Which of the points on the graph above represents the neutralization point of the reaction? Now, the neutralization point is typically that point where after that, the reaction rate goes down because there's basically no more of what was there before. So if it's being neutralized by an acid, the base, there's just no more base there for there to be, you know, any more reaction, right? So here we have our graph. And so what I'll submit to you is that point Q is where we have the neutralization point of the reaction, right? So that's where both of our lines will meet point Q, right? Because at that point, it's completely neutralized, right? The sodium hydroxide is completely neutralized, and so there's no more base to be reacted, and so the temperature just steadily declines afterwards. All right, number 31. So here we're looking at, you know, some apparatus for electrolysis. If substances containing 1 mole of solute per dm cubed are investigated, what substance would cause the bulb to glow the brightest? Any ideas for this one, guys? So it's essentially asking you which one is the strongest electrolyte, right? And for here, that would be C sulfuric acid, which is a very strong acid in comparison to ammonia, ethanoic acid, and water, which are not very strong electrolytes. All right, let's look carefully at this one. Which of the following diagrams illustrates bonding in chlorine?
D.
D as in dog, right? And that's because we notice this as being 2 halogens. 33, which of the diagrams illustrates bonding in oxygen?
B.
B as in boy is correct, right? So here we have, you know, 2 atoms with a valency of 6 sharing 2 bonds, right? And so that would be oxygen. 34, which of the following correctly describes the reaction above? So above here, we're seeing an acid reacting with a base to form a salt and water. What's that called?
Neutralization.
Beautiful, neutralization. 35. A compound, when treated with concentrated hydrochloric acid, gives off a greenish yellow gas, which bleaches moist red litmus paper. What would you guys say this one is? Which gas is given off?
Chlorine.
Chlorine, beautiful. Which reaction involves the boiling of a fat or oil with aqueous sodium hydroxide or caustic soda?
Saponification.
All right, what is saponification? Any ideas? Why would you say saponification?
Because it includes the boiling of a fat.
Mm-hmm. With?
Aqueous sodium hydroxide.
All right, beautiful, right? So this is the textbook definition of saponification, essentially. It doesn't just have to be sodium hydroxide, honestly, but essentially, yes. That's what this would be, right? Saponification. All right. Number 37. A current of 5 amperes was passed for 193 seconds through a solution of copper 2 sulfate using copper electrodes. What is the mass of copper that would be gained and where would it be gained? Now this one can be a bit tricky, but I saw that you guys did a question similar to this in the paper 2 session. So I'm gonna give you some time to work it out. I'm gonna give you about 2 minutes to work it out. And if you have any answers, you can let me know. If you don't remember how to do it, I can do it and show you guys. You have to let me know if you don't remember. All right. Any ideas about this one, guys, for 37? You guys remember how to tackle 37? All right. So I'm gonna go through 37 with you now in the interest of time. So essentially what we would start by doing is recognizing what we have at our disposal, right? So the Faraday, which is this that they gave us, represents the amount of charge for 1 mole of electrons, right? Now we need this in terms of figuring out the number of moles of copper, right? But just let me walk you through it, right? So current for I is represented by charge over time, right? Therefore, charge is equal, which is represented by Q, is equal to current times time. Here, that would be 5 times 193 seconds, which would give us 965 coulombs, which is what charge is measured in, coulombs, right? Let's get on a little bit more on this. All right. Charge is measured in coulombs. So we know the Faraday, and the Faraday is 500 coulombs per mole of electrons, right? So we need to find out if we have 965 coulombs, how much electrons were released, right? So, or how many moles of electrons were released. So to do that, the number of moles of electrons would be the 965 coulombs that we got over the Faraday 96500, which is coulombs per mole, right? And that would give us a total of 0.01 moles, right? Now, if we're looking at it, in the production of copper from a solution of copper sulfate, we'll start out with Cu2+. And we have to add 2 electrons in order to get 1 copper atom, which means the relationship or the ratio of copper solid to electrons is 1 to 2. So that means if there is 0.01 moles of electrons, then there is half that number of copper molecules or copper atoms being formed. And so X would be equal to 0.01 over 2 to give us 0.005, right? But that's moles. Now, in order to find the mass, we would have to multiply the number of moles by the RMM, and that would give us 0.005 times 65, which would give us a total of 0.325 grams, right? So that already means that A and B cannot be the answer. So now we need to figure out where did this reaction happen, right? And so we remember that at the cathode is where reduction occurs, right? And this is what this is happening right here. Remember, reduction is a gain of electrons. So at the cathode is where this would happen. So our answer would be D. At the cathode, we have 0.325 grams of copper. The compound ethene is described as being unsaturated. What does this mean, guys?
C.
C, right? It has at least 1 double bond. Which of the following metals will react most vigorously with dilute acid? So this one is just asking you which of these metals are the most reactive.
D.
D as in dog, zinc, wonderful. Almost through with this paper, guys. Which of the following methods is used to extract aluminum? We saw this like 4 times already. A. Which of the following metals is an important constituent of chlorophyll? And we saw that that was magnesium. Which of the following options list all raw materials using the extraction of iron? And we said that that was air, coke, iron ore, and limestone. New question, which of the following compounds may be used to counteract the effects of acid rain on the soil? What do you guys think for this one? No ideas? So guys, if we're trying to combat acid rain, we have to use a base, right? Or a basic item. And the only basic thing here would be calcium oxide. Next question, which of the following is most likely identifies P and the Q? If we're looking here, what are the functional groups we're seeing, right? So we saw an alcohol for P, so that means A and B are out. What about Q? Q is an ester, right? So it's an alcohol and an ester. What is the correct structural formula for X? So remember now, this is 1, 2, 3, 4 butane, right? Now, if we're adding bromine to that, we're going to what's going to happen is that there's going to be 2 additions of bromine to this, right? To this structure. And so it's going to take the place of that double bond. So it has to be on those middle 2. So it'd be B as in boy. Looking at the compounds that we have here, which of the compounds above has a fruity odor? Anyone know about which one of those compounds that have a fruity odor? All right. Well, essentially, it's important to remember that esters tend to have a fruity odor, right? And the only ester that we see here is C as in cat. Which of the compounds above reacts with sodium carbonate to produce a gas which turns lime water milky? But we know that to produce a gas that turns lime water milky, when we're talking about a base like sodium carbonate, or rather more so a salt like sodium carbonate, it would have to react with an acid. So that would be A as in apple. 48, which of the following is produced when carbon monoxide reacts with iron 3 oxide? Any ideas for this one, guys? In the interest of time, this will be our last paper. So when carbon monoxide reacts with iron 3 oxide, what is produced? All right. So what is produced is iron and carbon dioxide, all right? I can tell everybody is tired, so I'm just going to finish up so that you have something to look back on when you guys are reviewing later on. So hexane is an alkane with 6 carbon atoms per molecule. Which of the following is the formula for hexane? Now remember, we said that for hexane, we had, or for alkanes rather, we have a general formula of CnH2n plus 2, right? Now, if we have CnH2n plus 2, that means we can look here and we'll see that formula played out, right? So that's where we have C6H14, right? Number 50. Compounds 1 and 2 are known as, and so we're looking at this, and what jumps out immediately is that these are isomers, right? But that they're also alcohols. So these would be isomers. So the answer would be A here. These would be isomers of C3H8O. All right, we're on our last few questions. Steel is often used in place of iron because, and the reason for this is that it is stronger, right? You wouldn't want to use something because it's more susceptible to corrosion. Steel is generally not cheaper, but then also if it had a lower melting point, it couldn't be used in the capacity that we want it for. So it is stronger is the better way of deciding or stating why people use steel instead of iron. Which of the following statements is or are true of alkenes, right? So we know that alkenes undergo addition reactions and they also react with permanganate. As for substitution reactions, not so much. So the answer for 52 would be B as in boy. Which of the following tests can be used to distinguish between an alkane and an alkene, right? Now, for distinguishing between an alkane and an alkene, the most important of the tests that you would probably, undergo would be the use of that bromine because it will decolorize the bromine, right? But then what about the other two, right? That's an important question. What about the other two distinguishing features? Well, when distinguishing between the two, the best way would just be to add the solution of bromine. There's not so much of a difference in conductivity. So I would say that the answer would be 1. Right, because they produce the same compounds when they burn. So I would say 1 only, or A. What type of reaction occurs when zinc metal is added to copper sulfate solution? So when zinc is added to copper sulfate solution, we have A, displacement reaction taking place because zinc is high up in our reactivity series than copper. So what you'll form is zinc sulfate, and then your copper would just be on its own, and so it would start precipitating out a solution. Our final 6 questions are upon us. So 55. During the manufacturing of ethanol by fermentation, the gas evolved from this process, right? As we saw earlier, it's carbon dioxide, and carbon dioxide turns lime water cloudy. 56. Which of the following is a natural source of hydrocarbons? And as we saw before in the previous papers, that would be petroleum. 57. all members of a homologous series have similar what? So they have similar chemical properties, right? Not necessarily physical properties, boiling points or densities, which are physical properties, right? And we said the reason why they don't have similar physical properties is because as we move down a homologous series, we're differing by CH2. And so what you'll find is that as they get heavier and bigger, their physical properties begin to change. 58. Which of the following is the reason for adding cryolite to pure alumina in the extraction of aluminium by electrolysis? And the reason for this is that it lowers the melting point. 59. Which of the following substances is a product of halogenation with methane, right? And so we saw this one before as well. Because we're looking at an alkane, it's a substitution reaction. And so you'll get the halogenated, alkane. So it's called a haloalkane. But what you also get is a hydrogen halide, right? Or hydrogen chloride. Our final question. Which of the following compounds is not formed from condensation polymerization? Not formed from condensation polymerization. So when we're looking at it, condensation polymerization makes polysaccharides, polyamides, and polyesters, but not polyalkenes. Remember, we said that for polyalkenes, we use addition polymerization. And that's it for today. Thank you guys so much for coming.
Thank you, Miss, for helping us.
No problem. Have a good evening, everyone.
Same to you.